Hi everyone. Good afternoon. It's dot 12. So welcome everybody. I can still see a lot of you trickling in, so I'm going to just give everybody a couple of minutes to settle down. We have two back-to-back sessions. Yes, hi Hemant. Good noon. Uh, hi guys. Hi Lokesh. Thanks for making the chat already alive. Is my voice echoing? Richa is saying my voice is echoing. Is it okay for everybody else? Just say okay. Okay, for me, it's clear. Okay. I'm just going to take it as an okay. Everybody said it's okay. No issues. Awesome. Thanks for confirming that. Welcome again, guys. We have a packed weekend, 2 days of touching upon concepts that you were just thinking about, but now you'll see it in action. Thanks to our instructor who's joining in today, Justin, who's already here. I'll introduce him shortly. I'm just going to tell you what's going to happen over the 2 days, that today and tomorrow. Tomorrow we are going to meet again at the same time. We are going to, this is what we call the AI Launchpad. This for technical professionals who have been dabbling into AI, but they don't know what in a structured way what is or haven't had the time or resources to sort of get a more structured view on how to build an AI agent, understand the system design behind it, use that bridge, and then build multi-agent systems and see it in action. All these four things we are going to do uh, today and tomorrow, thanks to Justin, who's joined in. I'm going to introduce him shortly. I'm just giving everybody, I can see hundreds of them still joining in. So I don't want anybody to miss anything. While I'll just go ahead and share my screen so that we can get started. I hope my screen is visible to everybody. Just a soft yes would be great in the chat. Yes, amazing. Okay, I got lots of yeses. Great. Awesome to see that participation already, guys. So I'm Niyati. I work with Interview Kickstart. What do I do at Interview Kickstart? I majorly work in the India market, and my day job is to talk to thousands and thousands of tech professionals like yourself and bridge that gap in terms of skills that are needed by our hiring partners. So day in and day out, I'm trying to figure out how should we produce our learners who have the best and the latest knowledge on whatever is happening in the AI era, and how to keep them up to date in a way that has a long-term impact on their career. So that's in short what I do. A number of things in that fall in that, but maybe a topic for some other day. So let's get started officially. The day one agenda is right in front of you. Like I said, you'll see Justin build uh, maybe for some people it would be a first AI agent that they are seeing built from scratch. For some of them, it's you guys have already dabbled into it, and that's great. He'll then, in the second half of the session, introduce you to the system design bridge. Basically, understand what's the architect behind it, what is the tech stack behind it, and we'll understand that in detail. I will also come in between and talk to you guys about how you can take your learning beyond these 2 days. And if you're looking for a more detailed, structured roadmap, that's what I'm going to talk about for about 10 minutes in between, right? I'm also, this session is recorded. We will share recordings with you, so don't worry about that. You'll get all material. I'll also post the link to our Slack and Discord communities where we keep sharing resources. You would have also gotten an email about that we'll share some free resources. So all of that will reach you. Do not worry about that at all. My suggestion would be to sit back and relax and focus on the session, right? Uh, and I'm also going to launch a couple of polls during the session. So that will help me understand your background, what are your career aspirations, what are your blockers, so that I can come in and talk about that and help you unblock some of them if possible, right? About some of you already know about Interview Kickstart. I'm just going to take a minute or so to just introduce ourselves officially. We have been in this business for about 12 years plus. We started in Santa Clara in the US, in the Silicon Valley, and we started with providing customized interview preparation for about 18 tech domains. So when I say 18 tech domains, we customized it for separately for a backend engineer or a technical program manager or an EM or product managers, data engineers, all of that, right? So uh, that's how we started to stand out, and we brought the same model even in our AI up leveling. So all of the tech professionals who take up our courses have customized tracks, have customized projects, have customized interview preparation, and we're going to talk about that more little later. What's our secret sauce? Our secret sauce is people like Justin, who's our instructor for today. We have about 700 plus Mang Plus instructors who work with us. So in their day job, they are actually scaling AI systems in companies like Meta, Google, Amazon, Netflix, OpenAI, Anthropic. And then over the weekends, they come and teach you the same thing, right? So there is no lag of information. The amount they are spending on in their companies to build these systems, all of that latest knowledge is brought to you through our programs. And we are going to talk about our programs a little later. We have about 27,000 learners in India and US both. And you can see some of the success metrics on your screen regarding compensation that our learners have been able to achieve. On an average, you see an uptick of about 18 to 22 lakh per annum in your salary at the increment that I'm talking about. That's the increment on an average that you can see from whatever base you are at as of now. I already spoke about our secret sauce, so I'm going to quickly hand it over to Justin. Justin, thanks for joining us again. And I'm super excited to do this session with you again because whenever you do this, we have great engagement and learners always have great compliments for you. So thanks for joining again. So Justin is a staff AI engineer at Analog Devices, which is a company in Ireland, Limerick. He is actually a homegrown boy. He's a BITS Pilani pass out, and about almost now a year back, he shifted to Ireland to pursue his career opportunities that you can see in front of your screen in Analog Devices. So he has over almost a decade of working in extensive AI roles that you can see in front of your screen. And I can't think of a better person who can take sessions today and tomorrow from scratch to deployment. I can't think of a better person to take this session. So, Justin, thanks again for joining in. I'm going to hand it over to you guys. And Justin, you can go ahead, share your screen. And while you're doing that, I'm just going to remind everybody that I'm going to share a poll that you guys can answer and help me know you better. So enjoy the session. All of the material I'm going to keep posting in the chat. We also have our program experts on the call. So if you need more information, I'm going to share the calendar link. Just, set up a meeting with them at your convenient time. Over to you, Justin. Thanks.
Yep. Uh, Thanks, Niti. Give me a moment. Let me just share the screen. Yep. I hope you guys can see my screen. Let me know if there are any issues. I hope you can hear me as well.
Yes.
Is
As of
there
now,
no
you're
issue
clear.
with my? Okay, perfect.
I think there's
Hi
a
everyone.
little bit of it was just
Jitter.
there initially, but I think now it's super clear.
Mhm. Okay, perfect. Uh, Thanks everybody for joining in. My name is Justin Joseph, and I'll be your instructor for the day. So, I'll be attempting to walk you through a multi-agent system on how the internals are built and what are the different components involved in it, and also share you a live link of the system so you can play with it. So that's our objective for the day. So today's would be a high-level overview of the system, and tomorrow we'll go into a deeper dive into the system. So, a quick introduction about me, first of all. Uh, I'm Justin Joseph, and I work as a staff AI engineer for Analog Devices at Limerick, Ireland. The organization it's a US based organization, and we have the headquarters in Boston. And I'm currently working at the European headquarters located in Limerick, Ireland. So let me just check the chat. Yeah, I hope you can hear me. Perfect. All right. Um, I hope it's not echoing from my end. Uh, All right. So, with respect to my work, I work on building multi-agent systems and multi-agent AI systems that facilitate industrial automation. So that's what I do. And recently, we have been experimenting, or we have been researching a lot with physical AI. Hope you can see my screen and hope you can see what I'm writing. So we have been experimenting extensively with physical AI. That means incorporating intelligence to robotic systems is what we generally talk about physical AI. So the idea is that these agentic systems that we usually build, they are software systems, but integrating them with the hardware or making robots autonomous or capable of decision making is the difficult part, and a lot of research and money is flowing into it. So we are also working towards it. So we had some demos at the NVIDIA GTC regarding some dexterous hand manipulation recently a month back. So we are working towards it. Let's see where it heads in the coming years. All right. So I have around 10 years of experience in uh, AI systems, starting from classical machine learning. Then I moved to natural language processing, then computer vision, then industrial automation. And within industrial automation, currently I'm working on robotic agents. All right. Let's get started with today's session. So today we are focusing on building a multi-agent system. And in this multi-agent system, we will be using LangGraph, OpenAI, Chinook, and also Gradeo. Chinook is the database data set that we use. We'll talk about all that in detail. So, yep. The objective is that we have multiple agents here. And why do we have multiple agents is because each agent is responsible for doing something specific. And we will discuss about all of the agents that we have, what the agents are capable of, why do we have multiple agents, how are they orchestrated, which is the main part, and where does all of this LangChain or Gradeo or OpenAI or our database, everything comes in the picture. All right. So the primary difference between, so whenever I talk about an agentic system, I need to talk about LLMs because I see a lot of people have a misconception about LLMs and agentic systems. First of all, LLMs are purely text in, text out. You pass in a query to it and it generates a response for you. That is what large language models or LLMs are about. Now, on the other hand, agentic systems use these LLMs as the brain. And the agentic systems provide LLMs access to certain tools, APIs, or databases, etc., which it can use whenever required. So, depending on the user's query that is coming in, the LLM decides what tools to trigger. And the agentic system triggers the tool for the LLM, and the LLM provides the input to the tools, and the tool is triggered. The response is received from the tool, given back to the large language model. Once again, the large language model performs further reasoning or thought process in order to provide you the response. This is what the difference between an agentic system and a large language model is. So, why do we need an agentic system? Is because if you just have the large language model, the large language model has tendency to hallucinate. The large language model will not be trained on the current data that we have. And the large language model might give out incorrect information. So we need to prevent all of this. We need to make it more targeted, more specific, and more accurate, which is why we are building an agentic system. So the easiest explanation of what an agentic system could be. Also, you are currently in today's session. You will be going through a specific kind of system called the reasoning action system. Wait, reasoning action, which is also known as React. So the idea is that like I told you, the agentic system has LLM as the brain, and it has access to tools. LLM is there, and there are tools, and the LLM can decide to trigger any of the tools whenever required. So, what happens here is that tools or databases, by the way. So, the easiest example that I could tell you about the agentic system is you go to ChatGPT or you go to Google Gemini. Both of these are agentic systems. They are not LLMs, by the way. ChatGPT uses GPT 5.2 or GPT 4 or mini or any of those LLMs under the hood. So, ChatGPT, the website, is not an LLM. It's an agentic system. So, when you ask a query, like for instance, what is the weather in Bangalore today? Then the LLM receives this question. But the problem is the large language model, the GPT 5.2, for instance, is not trained on today's weather data. So it has to pull the weather data from somewhere so that it can respond to your query. Your query might be something like, what is the weather at Bangalore today? Or the query might be like, should I carry an umbrella in Bangalore today? Okay, so in order to respond to this query, the LLM thinks about the query and realizes that, okay, I need the weather data to answer this. And it looks at the tools that are available. And if it has access to some kind of tool that provides the live weather, then it can trigger that. And ChatGPT has access to, if I remember right, it has access to the weather.com website API. And that API is something that anybody with access can call. And in order to call that API, it needs two parameters. One is the location, and another is the date. So the LLM's responsibility is to create the input format, which consists of the location, Bangalore, and the date, 6th of June, 2026, and then trigger the API. So the LLM decides that this is the tool, among all the tools that I have available, this is the tool that I need to trigger, and it creates the input for the tool. Then the agentic system implements or runs the tool with this input that is given. The agentic, uh, the weather API gives back the weather that it is sunny, 32 degrees Celsius, humidity so and so, precipitation is nil, etc. And now the LLM receives the response back from the API, understands that. And then the LLM says, okay, based on the information of today's weather, you do not have to carry an umbrella. So this is what an agentic system is about. It has access to tools. The brain is the large language model, and the tools are called whenever required, as per what helps to answer the user's query the best. So this is what an agentic system is generally about. And when I talk about the reasoning action agentic system, the idea is a bit more nuanced, but it's very related. So the reasoning action system is a query is asked, then the LLM tries to understand it, reason it, and based on that, it triggers a tool, and that is the action. And then the tool's response is received back. And based on the tool's response, it performs reasoning once again. And then it decides, should I trigger another tool or do I have adequate information to answer the user's query? And then if it does not have adequate information to answer the user's query, it triggers another tool. And then it waits for the response, receives the response, and performs this again, reasoning followed by action. And then based on the output of the action, reasoning again, followed by action again, until the LLM decides that I have adequate information to answer the user's query and then performs the response. So this is known as reasoning followed by action. And we will be looking at a React system today. I hope the analogy, the example, and as to why agentic systems are different from LLMs, I hope all of these are clear. One moment. Any prerequisite for today's session? I'll try to cover it in such a way that there are minimum prerequisites. Okay. Are these LLMs already trained? Thank you very much. Yes. So these LLMs that we talked about, for instance, the GPT 5.2, or even the open source LLMs, GPT 5.2 is from OpenAI. So in order to use that, you need to purchase the API key from them so you can use that. Or if you're interested in open source LLMs, there are a lot of open source LLMs as well. Like, for example, the Llama family of models. Um, these are pre-trained on huge corpuses of data by researchers so that they learn to perform reasoning, they learn to perform conversation, all of this. So these LLMs are pre-trained, and we are leveraging these pre-trained LLMs to do our tasks. Because why would we reinvent the wheel if it is already available for us? So if you want an open source model, there are many models available out there from DeepSeek to Llama. And if you want paid models, you have the Claude models, you have GPT 5.2, you have the Gemini, a lot of options available for you as well. So using the LLMs as the brain, pre-trained LLMs as the brain, we'll be building an agentic system which brings together these LLMs, the tools, the databases, or whatever is required to facilitate building a multi-agent system that can solve our problem. So one another example of a multi-agent system, I didn't go into a multi-agent system. An agentic system could be um, a flight booking application. So you tell the agentic system that this is the flight that you want to get booked, and then the agentic system can trigger the backend API that can provide you the details of the flight. And once you finalize the flight, it can perform the booking for you as well. So um, a lot of agentic applications are available out there these days, and most organizations are looking to migrate many of their systems to agentic systems as well because of the capability of reasoning, thought process, and capability of being autonomous to a great extent. All right. Where this agent will be host? Very good question. You can deploy the agentic system in AWS, Azure. You can deploy it in your own system if you want. We are in today's session. We'll be looking at Hugging Face Spaces, and Hugging Face Spaces is a platform where you can deploy your projects. And just that you need to make it open source. That's all. So there are a lot of options for deployment as well. Okay. Navina, to answer your question, yes, we are not providing any of our data for training. We are not training the model at all. We are just taking the pre-trained LLM, which someone else has trained for us. That means it's not proprietary. We'll be using the OpenAI LLMs. We are just subscribing to them, or we are just using their API. And we are using that LLM's reasoning capability and coupling them with our tools, databases, or whatever that we want, if required, in order to make it agentic. So we need not provide data to train the system. That's the important part. All right, let's look at the system today. Okay. Yeah. So the difference between this and the traditional chatbots is that the traditional chatbots generally focus on keyword matching. And one moment, I think we have a slide for that. So in today's agenda, we'll cover a lot of things, but this one, yes, I just wanted to touch base on this part. Uh, okay. All right. So the traditional chatbots predominantly operate on keyword matching. And when the user tries to phrase something in a bit confusing way without the direct keywords, where you have to understand the intent behind the user's query and then understand what the user is looking for, that is the problem, and that is where the traditional chatbots fail. And even if you use the large language models, which are pre-trained in understanding language, still they are prone to hallucinations. So if you remember using ChatGPT back in 2022, when you ask something a bit confusing, ChatGPT always used to hallucinate. These days, they are much more grounded because they have a lot of other tools, APIs, databases that it can access in order to provide you better responses. But back then, it was just a large language model, not an agentic system. So it used to hallucinate a lot. No, now we need to mitigate this and we need to make it grounded based on our requirement. And our requirement is to build a chatbot for a music store. That is what we are going to do today. So, in order to build a chatbot for a music store, we need multiple aspects. Like, for example, understanding the kind of albums that we have access to, understanding the invoices, purchase receipts, preferences of a user. All of this is to be factored into account before responding to the user's query. Now, we cannot use a standard LLM here because if you use a standard LLM without making it an agentic system, then it will not have access to the tools or the databases or the user preferences that I just talked about. Now, in this project, we will be bridging all of this. We'll be having a structured SQL data access to actual data. We'll have a multi-agent system running so that the right agent focuses on the kind of query that the user asks. And this could be verification of the user credentials. This could be uh, having a memory so that the agentic system can remember what the user's preferences are. And it could be, it is also An agent that looks at the database that we currently have, so that it doesn't hallucinate, so that it doesn't say that, okay, let me play you Thriller by Michael Jackson and then say that, okay, I do not have access to that song, for instance. So in today's session, we'll be looking at a digital music store. So I'll come to that. Before, give me a moment. Yeah. So we will be covering multiple aspects, starting from the core concepts and definitions. And that means we'll be talking about agents, which I'm doing right now. And we'll be talking about the system architecture overview. We'll be talking about how the database looks like. We'll be talking about the different agents that we use. And also, we'll be talking about the memory system. I'll give you a high level idea as to what the memory system is. Give me a moment. For all of this, we need to engineer proper prompts telling the agents as to what to do, what not to do, all of this. And then finally, we'll take a look at the flow of execution, and we'll also take a look at some interview prep questions that could possibly come out of this. So, the one thing that I did not mention here is what are the agents that we use? We will talk about as time progresses, and currently, the memory system here. So, earlier I was telling you that the LLMs have access to tools, databases, to make it agentic. I did not mention you one thing. It also needs memory. That means if you just have an LLM, these LLMs are stateless. I know I'm using this fancy terms, but I'll try to help you understand it in the easiest way. Stateless means when you have a follow-up conversation with the LLMs, the large language models, it does not remember your previous conversations or your previous interaction. So you might be having, you might say that, okay, I prefer cars over two-wheelers. Now, the agentic system says that, all right, do you want suggestions for cars? Then, in the next query that you're going to say, yes, based on my preference, suggest me some vehicles. But the problem is these LLMs are stateless. And because they are stateless, they do not know what you mentioned before. So, in order to mitigate this, you need to incorporate memory. And a memory could be something as simple as a list, to be honest. In Python, it could be something as simple as a list, which consists of the past conversation history, which you will pass to the LLM so that the LLM knows, okay, what happened before. So based on that, I need to provide response to the user's query that the user has asked right now. So this is what memory is about. And memory is used to mitigate or to bridge the stateless nature of LLMs. So combining all of this, LLMs, tools, databases, and memory, we have the agentic system. Now, we have multiple agents which focus, which can do different memory capabilities, which can have access to different databases, all of this. But the multiple agents work together in solving our business use case. And we will talk about what it is in detail. All right. So I did mention what memory is as well. One moment, I see something in the a lot of things in the chat. Uh, Voice is low. One moment. Can you guys hear me properly? Okay, perfect. Thank you. Thanks for the feedback. Got it. Um, All right. So there are a lot of questions with respect to security of the LLMs as well. So there are multiple ways that organizations handle this. Either you can subscribe to LLMs handled by organizations like OpenAI, for instance, or you can have your private cloud within which you have LLMs of your choice. That is what many organizations do, which have data policy, data privacy requirements. So this is as detailed as I can go at this moment because I have to cover a lot of ground here. So and also, there are security guidelines and guardrails which we use for agentic systems to prevent data leakage, for instance. And also, there are issues with um, people trying to, I mean, users trying to give certain prompts and then try to uncover API keys, try to uncover the data and underneath all of this. So you should be creating a system such that uh, it is robust to all of this. All right. Um, Okay. Now, our use case. So we were talking about our digital music store. So imagine something similar to Spotify or iTunes, but something much smaller. And we have a customer service chatbot or a customer support chatbot that can support the users of this. So think about it like you're on Spotify or the Spotify you have at home. So for this application, we have a customer service chatbot. Now, the customer is capable of doing four things in our system. One, the customer should be able to browse the catalog. That means the customer should be able to ask about the different genres, artists, albums, specific songs, if any, all of this. Now, the agentic system should then query the database. And the database is a SQLite database. And the agentic system should be capable of querying the SQLite database and then provide the exact data that the user is asking. Like, for example, here. So this is the music store customer service assistant. So I just mentioned the customer ID at the start, and then it asks, "How can I assist you today?" And I asked, "What rock albums do you have?" And then it says that it has a total of 1,309 rock tracks in the catalog, and it provides us some examples. And these are from the SQLite database that it queried depending on the user's question. So you can ask a question here and it can provide you the response. So let me just share you the application. If you want, you can. I'll share it a bit later because I know everybody's going to use it. So it might get bombarded with requests and it might go down. So probably I'll share it with you a bit later. Um, so the first one was browsing the catalog. So we have a SQLite DB. Depending on the user's query, it should browse the catalog if required. Now, the next one is to verify the user's identity. Sorry, my bad. Verify the user's identity. So the user has a customer ID, the customer has a phone number or an email. So based on this, the system is going to check against the database before letting the user access the account sensitive information. And the third one, once the user has verified their access to the application or access to the database or access to the application, I would say, and then they can access their account data. Like, for example, any past invoices, or any purchased tracks or any billing details and all of this. So just like your Amazon account or your Spotify account, you log into it and you can see your favorites, your playlists, your past invoices, etc. But here it is limited to purchase history, past invoices, billing details, personalization, etc. And we don't have something as robust as a playlist or anything because we are trying to keep it small. And then the fourth thing that the customer should have access to is, or in the customer's chatbot, that the customer should have access to this feature is that the memory. And that means based on the user's requirement or based on the user's interests, the suggestions will be provided. So that means the user comes back after logging out, the user comes back and the user said that they are interested in ACDC or rock or pop or something like that. And then that is the personalization that the system should remember. And then the system should respond to the user when the user asks, "What are my preferences?" or based on my preferences, suggest something. So the system should remember that the user is interested in rock music, for instance. So all of these capabilities are what we are going to build today. So I will not be walking you through step-by-step instructions on how to get it built because it generally takes a bit of a time to to help you do that. But instead, I'm sharing you a GitHub repo. I'll just share in the chat. One moment. So this GitHub repo consists of all the code as well as the complete documentation on how to set it up, how to run it, along with the complete documentation of the architecture as well. So there are detailed instructions on how to run this. For this, you will have to use Python's virtual environment and you will have to containerize the built application in Docker. And I'll explain Docker as well. So the idea of Docker is that traditionally, when you build a system in your when you build an application in your system, it need not be an application. It could be a simple Python code. When you run a Python code in your system, and then you say that okay, it works great in your system, and then you share a copy of that Python file to me, and I try to run it, and I'm facing errors. And these errors could be because of Python packages. These errors could be because of the Python version difference that you and me are using, or it could be the difference in the system that you and me are using. You could be using a Mac OS, I could be using a Windows OS. All of these could be the reasons as to why the code is not working. And please remember that we are just talking about one code file. So this code is not working in another system. So the classic issue of it works in my system, but it is not working in production, or it works in my system, but it is not working in your system. This issue is to be mitigated. And the answer to that is Docker. So rather than just passing the file alone, you will be containerizing the file along with the requirements to run the file, like the Python version, the required Python package is required, all of this bundled together as a Docker container. And this Docker container can be spun up in any system and the application can be run. So no more issues of it works in my system, but it doesn't work in another system, because we are not just passing the file or the application, but also the application bundled with all its requirements so that it can be run on any other system. So that is what Docker is about, and which is why we are Dockerizing the system. I think I saw it somewhere. Yeah, Dockerizing the system before deploying it. All right. So the complete details of how to run the application, the complete details of the code base, how to use the application, how to deploy it, everything is provided here in detail. So we are not deploying it from scratch, because the deployment does take some time. So we have already deployed it for you, and that is what you see here, and that is what I was interacting with a moment before joining this session, so that I could show you this part. So this is the UI. By the way, the interesting thing is you don't have to build a UI from scratch either. There is something called Grad.io. It's a Python package that we use for building UI, simple UIs like this, so that you don't have to uh, create your HTML pages. All right, let's continue. Okay, so we discussed about the four different scenarios that our agentic system would be handling. Now, starting with the core concepts and definitions, and I did mention what an AI agent is and what is the difference between an agentic system and an LLM. So, what tools to call, observing the results of the tool, deciding what to do next, whether to call another tool or whether to respond to the user's query. All of this determined by the agentic system. Now, in this, we are talking about a specific system that does the reasoning plus action. So first, it does the reasoning, followed by action, and then it is a loop. It is like a while loop. So it performs the reasoning, it performs the action. Then, based on the action, it performs further reasoning. And then, if required, it performs a different action next time. And it performs a while loop doing this until the agentic system has enough information to answer the user's query satisfactorily. Now, the questions like what rock albums do you have? Um, I think I showed you just now. Yeah. What rock albums do you have? It provides me the response saying that from the database that it has access to, these are the rock albums. It has a total of 1,308 rock songs in its catalog, and these are some of the examples of that. Now, yeah, one moment. Yeah, 1 minute. Yeah. So we were talking about what rock albums do you have? Now the LLM performs a search in the music catalog, and now it performs a search by using some functions in the code base. And the function that it uses under the hood is the get songs by genre function. And it takes in the genre as an input. And this function technically executes a SQL query behind the scene that you will not see. Or you can see it, you can open the code base and you can take a look at it. But still, what I'm saying is when the user interacts with the agent, the user has no idea that a SQL DB is being queried. But so that is what happens in the get songs by genre function. So what happens here is when the user asks, what rock albums do you have? That is a user's query. Now, based on the user's query, the agentic system tries to think about it like what to do. So the agentic system understands that the user is looking for albums based on a certain genre. Now, the agentic system takes a look at the different tools that it has access to. And one of those tools is this Python function, the get songs by genre. And then that tool is triggered. So the reasoning was what to do. The action is what is to be done. So The agent does the reasoning, and then after that, based on the reasoning, it decides what to do, what tool to be triggered, and that is action. And once the action is triggered, under the hood, the SQL query is executed. And once the SQL query is executed, the SQL query's output is given back to the agentic system. Now, the LLM receives the output back from it. And based on the output, it observes the output. And the output is a JSON with 10 rock songs across the different artists. Now, the LLM decides, do I have enough data to answer the user's query? If yes, that is the end of the reasoning action. If no, further reasoning and further action takes place, like a while loop until the user's query, until it has adequate information to answer the user's query. Now, this is the reasoning action pattern. So, one moment, I can share you an additional link about this reasoning action, which can really help you. One moment. Yeah, got that. So, this is a YouTube video, short one, a 20-minute YouTube video explaining what reasoning action is, and also explaining the implementation of reasoning action without using any existing frameworks, and then by using an existing framework like LangChain. So you can go through it. I'm just sharing it in the chat for your use. Yep, here. I've just shared it in the chat here. I hope you can see it. Yeah. So this is a good video, short video, explaining what reasoning action is, explaining how to implement it with just prompts, and also then explaining how to do this using existing frameworks like LangChain. So let's get back to business. I know that you have a lot of questions. Multiple people have raised their hands. We will take your questions in a moment. But if I start taking questions right now, it will be a never ending loop. So please let's take it a while later. Okay. So we did talk about the reasoning action part. And the next thing that we have to cover is yes, we are using a framework to implement all of these multi agent systems. And that framework is LangGraph. So the answer of how do you build these agents, somebody had asked me in the chat, I remember, and the answer to that is LangGraph. So there are a lot of frameworks like LangGraph. For instance, you have AutoGen, you have Crew AI, etc., that are specialized at building multi-agent systems. And especially Crew AI is very beginner friendly. If you want, you can take a look at that. So, or Interview Kickstart's course is going to cover it for you as well. So what I wanted also LangGraph for sure. So LangGraph is one of the most popular agentic frameworks out there. Not an agentic frameworks, agent building framework you can call it, or an agent orchestration framework you can call it. Where the idea of LangGraph is that it is used to build multi-step AI workflows using dedicated graphs. This is the idea of LangGraph. Now we are going a bit technical. Now within LangGraph we have multiple components. The first component is the state graph. The idea of state graph is that um, this is a graph where every node reads from and writes to. So this is like a shared typed dictionary. Now, think of it like a whiteboard that all parts of the system can read from and write to. So when you're having a collaboration with your teammates, you might use a whiteboard to discuss your ideas and everything. So everybody can write in that and everybody can read from that. So that is the idea of the state graph. Now, the next one, I'm trying to keep it as intuitive as possible. And the next one is a node. And this node is a Python function, a simple Python function. And this node receives the current state as to what happened. And then it performs some work. And this work could be something like calling an LLM. It could be something like running a SQL query. It could be something like doing any other task that is required. And then the node returns the updated state fields. So this is the responsibility of the node, a simple Python function. Now, the next one is an edge. So I did tell you that LangGraph is based on the graph DB or based on the concept of graphs. So where you have multiple nodes, where you have multiple edges, the node is a Python function. We just discussed that. And now the edge. The edge is a directed connection. And this connection is between the different nodes. And the edges can be conditional. So that means they look at the current state, they decide what node to go next. So based on the current state, Using the edges, it understands what nodes it can go to next. So it is a graph-based structure where you have the nodes, where you have the edges, and where you have the state graph. Now the next part is a checkpointer. The checkpointer's responsibility is to save the state of the graph after every node executes. So I did tell you about multi-turn conversations. Multi-turn conversations means having back and forth conversations with the agentic system. Now, this checkpointer is what enables the multi-turn conversations. That means this is what it provides a capability of the system to remember what was said earlier in the current session, in the current conversation session, what was mentioned earlier. So that capability is imparted by checkpointer. So the checkpointer saves the state of the graph after every node executes, so that if the history is to be checked or if what happened is to come into the picture, the checkpointer is the one that we need to go to. Now, we have the nodes and the edges supported by the state graph and the checkpointer. And then we have the interrupt. The interrupt is responsible for pausing the graph execution completely and then to wait for human input and then resumes. For instance, it could be something like I tell the agentic system that um, what could be it? I tell the agentic system that I have a preference, and then it asks, "What is your preference?" And it is waiting for my response, and that is feasible by interrupt. It pauses the graph execution completely, waits for the input of the human, and then resumes the operation. Now, this is done for tasks like identity verification in our example. In our example of the music catalog support system or the support application, we have instances where we provide the customer ID or the customer email in order to prove authentication. So, waiting for the user's input before providing authentication is the responsibility of interrupt. Interrupt simply pauses the graph execution momentarily until the user provides the response. Now, this is what interrupt is about, and the last one is the store. The store is a persistent key value storage per user, and this is used to store the music preferences. And we are using it to store the music preferences. If it is a different application, you can use it for any other task as well. So, music preferences across the different sessions. So that means I'm if I'm user number 7, I say that I'm interested in um, classical songs, and then I shut down my session. I come back. I have a conversation with it. And it should ideally be remembering the preference of user number 7. So that is the reason as to why we have the store. So state graph stores the current state. Um, where every node can read from and write to. Then we have the node, which is an independent Python function, and we have the edge that connects the different nodes, and then the checkpointer that saves the state of the graph after every node executes, and you have the interrupt, which is responsible for waiting for the human's input, and then the store, which stores aspects like user preferences or music preferences for the different users. Now, you would have seen another example of store when you use ChatGPT, for instance. So you would have told ChatGPT that these are my interests, or you would have told ChatGPT that this is my job, this is where I'm based out of, this is my financial situation, etc. And in an unrelated conversation, probably a few days down the lane, when you ask for some financial advice, then it'll say that, okay, I'm comparing the stocks that you are suggesting. Now, based on your current financial status, this stock would be a better suggestion because of so and so reasons, even though you did not mention your current financial condition just now, but you mentioned it a few days back. So that is generally something that we call as persistent storage, persisting across conversations. So this store here is an I just wanted to use this store as an example for you to understand that. So that means um, in this context or in our application, the store is responsible for remembering the user preferences for a user across the conversations or across the sessions. That is the right word. All right. Now, a few key terms that you must know. Starting from tool. I did mention what tool is. Tool can be a simple Python function. It can be an API. It can be um, it can be any function, any API, any external resource that the agentic system can use to provide additional context or to fetch additional context for answering the query. Now, in LangGraph, for instance, wherever you see this decorator at tool in the code base, that refers to a tool. And this tool is something that the LLM can choose to trigger. And the agentic system triggers these tools and provides a response back to the user, if you remember the reasoning action part that we mentioned. And we have here a supervisor. The supervisor is an LLM that can decide which sub agent or which specialist to be triggered. So we will talk about the different specialists that we have here. So give me a moment. We will talk about the different agents that we have. We'll talk about the different nodes that we have. Don't worry about that. We'll do that in detail. But just understand that we have a supervisor, and the supervisor's responsibility is to trigger the correct agent depending on the user's query. So just thinking out loud, if you have a trip planning agentic system, the user asks to plan a trip to uh, uh, to a particular country, to Mexico for 10 days. And then the user's preferences and so are so and so. Now, there are multiple agents under the hood: trip planning agent, flight booking agent, hotel booking agent, etc. Now, the supervisor agent's responsibility is to trigger one of these sub agents depending on the user's requirement. The user's requirement is to plan a trip. So, the first agent, the planning agent, is triggered, and the user is given the itinerary, and the user says that, okay, this looks good, change the dates to so and so, and let's book a flight ticket. And in this instance, the flight booking agent has to be triggered. So the supervisor's responsibility is to understand the user's intent and then call the corresponding agent based on the requirement. And then you have the React agent. So different agents can be configured differently. And here we are using React, which is reasoning plus action. We discussed that in detail prior. And we have the state. So the state is the whiteboard that I mentioned earlier, that all the graph nodes can read from and write to, which is like the single source of truth. That is the state. And then you have the grounding. Grounding is mandate because we have to restrict the agent to answers based on our database, not based on what it has learned from public databases. So grounding it to answer only based on our requirements and our database um, is imperative. And then the next one is interrupt. We already discussed what interrupt is, waiting for the user's input. And then we have the in-memory store. In-memory store is the key value store of LangGraph that stores the user preferences. And we discussed that in the previous slide as well. And we have memory saver. The memory saver is to save the graph state within a single session. And we have parameterized SQL as well. So the idea of parameterized SQL is, instead of concatenating strings, if we have SQL queries using a placeholder like colon para, this placeholder is used instead of string concatenation. And this also prevents SQL injection. We can come into that later, but the idea is that this is used to execute SQL queries. That is the important part. And that is parameterized SQL, and that is what we use in our application to implement SQL queries. And I did tell that our database is SQL format, and we need to query the SQL in order to fetch the answers. Like for example, the rock songs that we have access to, for instance. And then we also have a thread ID. The thread ID is a unique identifier that identifies the user's current session. And this is important for the memory saver because the memory saver needs to be clubbed with the corresponding thread ID so that the current conversation can have adequate memory from past preferences as well. Now, these are just some of the key terms that we will be using as the session progresses. Now coming to look at the difference between an orchestration and a single agent. So I did tell you that we have multiple agents here. And why do we have multiple agents is because we need specialists capable of doing the different aspects, which is why we did not go for a single agent. The problem with single agent is that if one agent is responsible for handling everything, then the context grows bigger and bigger. And the single agent should have access to all of these tools. And there is a higher chance that it might confuse or it might make mistakes as to what tool is to be triggered. And when you add more and more capabilities to a single agent system, You are going to make it a monolithic architecture. That means you are not modularizing it. That means if something happens or if you want to make some changes to it, it is going to be a pain. So, which is why we are going for a multi agent architecture or a multiple specialized agents where each agent has a focused system prompt. First thing about system prompt. For those who do not know system prompt, when you build an agentic system or when you build any system using LLMs, you provide something called a system prompt. And this system prompt is a set of predefined text that we give to tell the agentic system that this is the responsibility of the agentic system. This is what it should be doing. This is what it is capable of doing. This is what it shouldn't do. This is what it has access to, all of this. So, with multiple specialized agents, each agent has a specific system prompt that we are providing, that the developer is providing, not the user. We have a set of tools. So, all the tools need not be accessed by all the agents. So, for instance, um, the tool which is used to fetch the songs by genre need to be used only by that agent which performs a search, not by every other agent. So, multiple specialized agents can have access to different tools. The behavior is also different. And also, it is independently testable. So that means if you want to add any new capability, make changes to it, it is much more easier. These are the reasons as to why multi-agent systems are generally preferred. You do not have a monolithic architecture, you have a well-separated modularized structure from an agentic perspective. And then we also have a supervisor agent that can decide which sub-agent to be triggered. So um, when you are to debug it, it is going to be much easier, and also it has proper separation of objectives. So that means the one single agent is not overloaded, and that means your use case or your problem statement will be solved in a better fashion rather than having one single monolithic architecture. All right, before going into the system architecture, any questions? I know we are around 1 hour into the session, so any questions? Oh, a lot of questions I can see in the Q&A. Give me a moment. Okay. Mm, Could you share all the links to email, including the session recording? So yes, I'm not sure whether an email will be provided, but the recording of the session will be shared with you. I think it will be a YouTube video or something like that. So you can use that in order to take a look at it. All right. Thank you very much, by the way. We have a subject matter expert in our chat who is responding to your queries as and when the queries are coming in. Thank you very much. What does the supervisor agent do? You have, for instance, I did talk about the trip planning agent. The trip planning agent has the itinerary or the planning agent. It has a flight booking agent. It has a hotel booking agent. Now, depending on the user's query or depending on where the user is heading to, you might either need to book a flight right now, or you might need to book a hotel right now, or you might need to update your itinerary. Now, the supervisor agent decides what sub agent is to be triggered based on the user's current state, based on the user's current requirement, and all of it. So, that is what the supervisor agent does. That means the decision has to trigger the correct sub agent. That is what the supervisor agent does. I see more questions in the Q&A. Mm, will we get a recording, day one recording at the end of day one? The SME is typing the answer. Bhuvan, you are saying that I do not have much coding knowledge, which is why I'm trying to keeping this session um, as what do you say, intuitive as possible. So we need to look at some parts of the code, but I'll try to make it as intuitive as possible. But the advantage is that when you join Interview Kickstart session, the sessions are structured in such a way that it caters to all the people, irrespective of whether you have coding knowledge or not. Also, the plus side is um, the sessions or the implementations, there are implementations with no code tools as well. So there are no code applications which can be used to build agentic systems as well. So you will have sessions on that, or you will have detailed understanding of that as well. So it's your choice as to whether to use LangGraph, whether to use a no code application like NA10, for instance, or it's your call whether to use something like Crew AI, which is more beginner friendly, because all of these are going to be covered in the actual course. So in the interest of time, I won't be able to cover all of these here, but I'll try to keep the coding part as intuitive as possible. Thank you. All right, Sri, you're asking is LangGraph similar to Oracle Agent Studio? To be honest, I've never tried the Oracle Agent Studio. There are more agentic systems or frameworks out there that I have not tried than the ones that I've worked with, because there are a lot of them. That's the thing. In agentic system, who will decide which tool is to be triggered? How the agent understands which tool is to be used for a specific action? Very good question. So at least in our application, we are using a reasoning action methodology. So that means the LLM is given information that these tools are there, and it is also provided the textual description of each of these tools. That what is this tool capable of, how, what is the input to this tool, what is the output from this tool, all of this. And based on this textual description, the LLM, the large language model, knows that, okay, I have access to these tools. Now, when the user's question comes in, it checks whether the user's question can be answered directly. If not, whether any of these tools can help answer that based on the tool's description and the user query. Now, it makes a decision as to this tool, this tool is to be triggered, and then it creates the input to this tool or the input to this API or whatever that tool is, and then the tool is triggered by the agentic system. So, to answer your question, the large language model or the brain of the agentic system is what decides which tool is to be triggered. Um, Tabish, you are asking, we have the Langflow and other agent framework. Why do you prefer LangGraph all over it? Are you referring to LangChain rather than Langflow? Because I have not used Langflow. So, the idea of LangGraph is the LangGraph is the most widely used agentic framework out there. So that is the primary reason as to why I went for LangGraph, because that is the most widely used and the most popular out there, and also it is from the LangChain family. So a lot of a lot of support is also there. Open source support is also there. Mahesh, are you going to cover security or observability and billing aspects post deployment? Not the billing aspects, but the security or observability. Yeah, we will be superficially mentioning that, but not in much detail because we have limited time to cover all of this. But to give you a heads up, you can try looking into Prometheus or Grafana. Prometheus is the tool that we usually use for observability of agentic systems, and Grafana is used to build fancy dashboards that can help us understand how these agentic systems are working. Another thing is try to look into Langfuse or what was the other one? Langsmith or Langfuse. So Langsmith is from the same family of LangChain, LangGraph developers. So you can use that for observability of agentic systems. And if you want to look at something open source, then you can go for Langfuse. I'll just type the names in the chat. Wait. LangGraph is for building the agentic system. Langsmith and Langfuse are for observability tasks. You can also use external tools like Prometheus and Grafana for observability. All right. Let's. I see a lot of questions flowing in, but I think let's continue with the session because if I have to answer all of those questions, I won't have enough time to finish what we have to cover today because we just got started. Now, coming to the high level system architecture. All right. In the high level system architecture, we have 5 layers, starting from the user interface. The user interface is what you saw here, this one. So this is built using Grad.io. So let's get back. Um, the user interface here is built using Grad.io. And this Grad.io is running in the browser, and this is what the customer types into. Now, Grad.io handles the session management and also displays the status as to whether it is up or not. And then you have the verification layer. The verification layer is the verify underscore info node. Let me just change the color. Yeah. So if you remember, a node is a Python function. So the verify underscore info Python function is responsible for verification. So before anything happens, we check who the person is, what the customer ID or the email or the phone number is. Now, you cannot bypass this because this is imperative. As if you want any past information, any billing invoice or anything like that, you need the customer ID. And then you have the memory layer. The memory layer has two nodes. One function or one node is a load memory. The load memory is reading existing preferences from the store before we process the request. And then the create memory. The create memory is to add new preferences or to save new preferences after after the user's preference. So the next one is the supervisor. We already mentioned what the supervisor is, which is the router, which routes a query to the correct agent. So the different agents that we have here are the music agent. I'll talk about the different agents. Hold on a moment. And then we have the sub agents and the tools. So we have two specialist agents here. We have the music catalog agent. One moment. Yeah. Yeah, sorry, the music catalog agent or the music react agent that has five tools. And this is responsible for hitting the database that you have in order to provide information about the music catalog that we currently have. And we also have the invoice agent. I would call it the invoice information agent. So we have the music catalog agent that fetches the catalog information by performing the SQL search. And then we have the invoice information agent that provides information as to um, what past billing has been done, what past invoices have been raised, all of this. Now, the first agent here, the music catalog agent, has five tools. We will discuss the five tools and what it does. The second agent, the invoice information agent, has access to four different tools, and we will also discuss what they do. Now, we discussed the supervisor, and the supervisor's responsibility is to decide which agent to be triggered, whether it is a music catalog agent or whether it is the invoice information agent. Now, all right. So, one moment. Every request that is going to come into the system follows a top-down approach. That means first, the verification. And after the verification, the supervisor agent decides whether to trigger the music agent or music catalog agent or the invoice information agent. First, the verification, then the supervisor, then the sub agents. Then, after that, the response can bubble upwards. That means the response from the music catalog agent can come back to the supervisor. So the supervisor can decide whether any other agent is to be triggered. Now, coming to the line graph execution flow. This is what I was saying. Yes. So the verify info is the place that you start from. So it checks whether you have a customer ID, whether you have an email ID or a phone number, any of these. Now, if the verification is failing, then it goes to the human interrupt. That means the human input. So if you remember interrupt, it waits for the human input. If the verification fails, it goes to the interrupt mode. The graph pauses. The customer is expected to provide the credentials. And once the customer provides the credentials, it goes back to the verification node. So this is what happens here in the verify info part. Now, on the other hand, if it is verified or if the verification succeeds, that means if the email ID or the phone number that you entered is valid, then it goes to the load memory part. That means loads the preferences of the customer. And then along with the preferences of the customer, the supervisor agent is triggered. Now, once the supervisor agent is triggered, the supervisor agent can do three things. One, it can either call the music catalog subagent. Two, it can call the invoice information subagent. So the decision is made based on the user's query. Or if there are off topics, like for example, I say that I prefer pop songs, then the supervisor is responsible for creating a memory that adds this information to the existing memory so that in the instance where the customer comes back again, that preference should be saved in that preference is to be loaded back from the memory. So that means that preference should be added to the memory in the first place. So the supervisor can do three things: either to call the music catalog subagent or to call the invoice information subagent, or to create the memory. Now, this is the complete flow, or this is a very superficial flow, I would say. And even this has its own complexity, which is why we kept this simple in a way that you can understand, in a way that I can explain, but with sufficient complexity. Now, we need to look at the tech stack here. I did tell that we are using LangGraph for orchestration purposes. So we are using LangGraph for the multi-agent orchestration. And you asked me, why did we use LangGraph and not LangChain? Especially when coming to multi-agent systems. LangGraph is preferred because that is meant to handle multi-agent systems, which LangChain was not meant for. You can build agentic systems using LangChain, but almost all the agentic systems that are in production that you see are not LangChain based. They are either based on any of the other frameworks or based on LangGraph. So, which is why we went for LangGraph here, because we wanted to keep it as close to the production setting as possible. Now, um, wait, we talked about OpenAI. So the LLMs that we use is from OpenAI. So you need to go to platform OpenAI. If you want to implement it yourself, you need to go to platform OpenAI. Um, wait, I might need to sign in. For some reason, it logged me out. So you need to go to platform.openai and you might have to subscribe to the API key. This is not the account that I use the API key from, so it will be empty here for me. And then you can create a new secret key, create the key, copy the key, and you can use it. And you can then it's like a pay as you go setup. So you can load the credits here and then you can use their LLMs. And we are using OpenAI's LLMs because they are quite good. You can use anything, Gemini, open source LLMs like Llama, um, or DeepSeek, etc. It's your call as to what LLM to use anyway. So we have an orchestration framework, we have OpenAI LLMs, and we are using the GPT-4 or mini LLM to be precise. And that is from OpenAI. Okay. All right. Now, the LangGraph supervisor. The LangGraph supervisor is a package that we use for routing. That means to decide which subagent is to be triggered. Now, for the memory or for the database, we are using SQLite. And we are using it via SQL Alchemy 2.0 for the database. Now, we need something to ensure that the inputs and outputs are in the structured format as we expect. And that verification is by Identic. It is used for data validation. The input is in the required format that we have, only then trigger the API. Because if the input is not in the expected format, why do we trigger the API? Because triggering the API, getting the error can break your system or can go into a fallback mode. So you do not want that. So before calling the API, use Pydentic in order to validate whether the input is in the correct format or not. Now, for the front end, we are using Gradeo. I mentioned that. And yeah, we did talk about the PostgreSQL part, and for testing purposes, you can use PyTest. And for configuration, we are using the Python virtual environment. So we did mention about all of that. So at the database layer. So we did mention about the high level architecture. We did mention about the different components involved here. Now coming to the database layer, starting with the data set that we have. Oh, wait. Yeah, the Chinook. That's what I was looking for. So the Chinook music dataset. One moment. Uh, I'm just, yep, got that. So this is the official repo of the Chinook database. One moment, I'm just sharing it. Looks like my system is a bit slow today. I have no idea why. Yeah. So this is the database that we are using. And this Chinook database has a lot of information about the different albums, different songs, etc. So we are using this database that we are using for today's session. So this database has information about artists, albums, tracks, the type of media, the playlist, customer, employee, a lot of things that we have. But the thing that we are interested in is the artist, the album, and the track. So we'll explain this in detail as to what aspects of the database are we using. Now, yeah, let's get back to the slides. Now, the Chinook database is what we use. So it is like a sample database that mimics a digital music store, like your mini iTunes, for instance. Now, this is one of the industry standard databases for demos or tutorials, and we took the same database because we can build our own systems using existing databases, using pre-trained models, etc. All right. Now, in this database, we have around 3,500 tracks. We have around 3,500 tracks, around 350 albums, around 275 artists, 25 genres, 59 customers, 5412 invoices, 2240 invoice items, and 8 employees. The most important parts here is the tracks. the albums, the artists, the genres, the invoices, because if you remember, we need past billing information for each user, the customers, the invoice lines, and the employees are not very important. It's fine because we are not utilizing that. We are utilizing only the customer information and the music information. Now, this entire data set will be loaded into an in-memory SQLite at the startup. No file input, no file output, nothing like that. It's in memory. Now, this is one of the reasons as to why the responses are quite fast. And each SQL query that you're going to run runs on the RAM, not on the disk. So, yeah, this is what I was mentioning. And why did we create it this way? To be honest, we wanted it to be simple. And we did not want to have an external DB where we fetch the information from because of the complexity purposes. Now, the schema for Chinook. This is the schema of Chinook. The idea is that we have information about employee, which we do not use much, but we have information about the customer. One moment. We have the invoice information. We have the different lines of invoice. And based on that, we are referring to a track. The track has genre, and also we have the album and the artist as well. I'm not going into the complete details of the Chinook schema because it takes time, and we just need to have a high level overview to understand what we are doing here. Now, um, the idea that the invoice contains the invoice line or the track belongs to an album and the album belongs to an artist. The track is also categorized by the genre, and the track is encoded as a media type. Ignore that part. Um, okay. Now, this is a high level relationship diagram or the schema of Chinook. Now, coming to the coding part. So I will explain the different Python files that we have. And all of these Python files are here, by the way. And I'm not going into the details of all of those Python files, but at least superficially, I need to explain what these individual Python files are about. So starting with the first one, the database.py. So we have the run query save function. And in the run query save function, one moment. Mm, wait. Yeah. Anyway, we have this run query files, run query save function. So in the run query save function, what happens here is, see, I'll try to keep it as simple as possible, starting with the text parameterization. So we need to have some mechanism which can prevent any SQL injection. SQL injection means instead of a query, someone types in instead of a chat, someone types in a SQL query, trying to inject that SQL query into our system so that this person can get the information that they're looking for. For instance, this person is not an authorized user, but this person wants the information from about a customer, and then they say that select star from customer table where customer ID is so and so, and this they try to inject it as a prompt into the system. Now you need to prevent that, and that is why this text function is there, and we are preventing SQL injection by using this function where we have a parameter binding so that an external SQL query cannot be injected into this. The idea is very simple. You cannot inject an external SQL query into this. That means the user's input is never concatenated into the SQL string directly. So we are just using a parameterized mechanism in order to handle that. It's fine. Even if you're confused, it is fine. Just understand that external users cannot inject a SQL query into the system. That's all. And then the JSON output. All the results that we have are serialized into JSON strings. And this is what the LLM receives. The structured JSON is what the LLM receives so that there is minimum room for confusion. Then we are also isolating the errors here. That means whenever there are errors happening, our exception handling mechanisms catch these errors because we need to prevent any issue from crashing the entire agentic loop. And the agent gets a message, error message, and the user exits gracefully without bringing down the entire system. And that is the reason as to why we have error isolation. And now, um, wait, yeah. And then we have some additional functions like, for example, normalized font. The idea here is that the font numbers can be stored in a different formats. So you need to normalize it in a specific format. That is the thing that the normalized phone function does. Don't worry about that. So the idea here is the database.py takes care of handling the data that we have here, and also providing the JSON output in the required format, isolating the errors, and also preventing the SQL injection. Now, as to how the database is loaded at startup, the idea is that there is a cached local file, Chinook SQLite.sql. This is there in the root of the project. You can check it. Now, by the way, is it there or whether you have to download it? One moment, let me just check. Yeah, the Chinook SQLite.sql. This is what I was saying. So let's get back here. All right. So this Chinook SQLite.sql will be loaded from the system. And then what happens next is this is cached locally. And once it is cached locally, the next startup can skip the download entirely. So you don't have to download it from the GitHub repo every single time you spin it up, because once downloaded, it will be a part of your system. Now, the next part, the step four, is to execute the SQL script into an in-memory SQLite connection using the execute script function. So do you remember that I told you that the SQL DB resides in your memory, not as an external database? And that is what is meant by this. The data set is taken and loaded into the RAM so that you can perform any kind of querying or anything on that. And then this entire connection is wrapped in a SQL Alchemy engine. And the idea of SQL Alchemy engine is that you want to make it thread safe. That means multiple users should be able to use it parallelly. You, me, and all of this 1,000+ other users who are there here. So this is the database layer, simply loading this to your memory, to the memory of the system that is being hosted, so that multiple users can use it concurrently because of SQL Alchemy. All right. If you're actually going for a production system, you actually need, what do you say, a proper DB or something like that. This is just as a project. But there are something that you need to do extra to make it a production system. We will discuss that as well. All right. Now, going into the agents and tools part. So we did talk about the agents part earlier. We did talk about the different agents that we have. We did talk about the reasoning action. We talked about the importance of tools. We talked about all of that. Now, starting with the supervisor. So I did talk about the fact that after the memory is loaded, after the user is authenticated, the next thing is the supervisor. So the supervisor's responsibility is not to call any tools. The supervisor is just a router. That means there is a supervisor prompt. And the supervisor prompt will say something like this. So you are the supervisor responsible for handling or responsible for calling the correct agent. These are your sub agents. And based on the user query, call the correct sub agent. Now, we have a routing table. And this routing table gives us information as to what goes where. So if the user's question is about a music or catalog, then it should call the music catalog subagent. If the user's question is about invoice or billing, then it should go to the invoice information subagent. If it is a mixed query, then that means the user needs some information about a song, and then based on that, the user needs to query the billing. Then it is sequential. First call the invoice, then call the music agent. Now, if it is a totally different query that is off topic, like for example, someone asking what is the weather today. Now, anything outside our domain, the supervisor responds directly with a rejection. So these are the things that the supervisor is responsible for, either calling the music query or calling the invoice query or calling them sequentially or telling them that you do not have the answer that we do not have the answer that you're looking for. Now, the supervisor prompt. So if you remember, I was talking about system prompt. So the supervisor, just like any other agent, is given instruction by the developer using a system prompt saying that this is what you should do, this is your responsibility, this is what you shouldn't do. And along with that, the supervisor prompt also mentions never to add any information that is not there in the subagent responses. That means this works against hallucination. This ensures that, or this enforces that the agentic system does not hallucinate. That means even the supervisor agent cannot invent new information. It cannot hallucinate. So this is how the supervisor prompt looks like. If it is off-topic questions, respond directly with rejection. If it is mixed queries, call the invoice information sub-agent first, then the music catalog sub-agent second. Never add information that is not there in the sub-agent responses. Also, it should have information as to the fact that the different agents are responsible for doing so and so. Now, the first sub-agent, we have two sub-agents here. The first sub-agent is a music catalog sub-agent. Next one is the invoice information sub-agent. Going to the first sub-agent here. I did tell you that this is based on reasoning action. So the music catalog sub-agent has multiple nodes. If I remember right, I was talking about two nodes and five tools. So the first node that you have here is the music assistant. The music assistant, uh, the see, music assistant is where the LLM is bound to the tools. So this reasons and decides whether to call a tool or not. Now, the next node is a music tool node. Now, this executes whichever tool the LLM chose. So this one chooses the tool. This one executes the tool. So this is the flow that happens inside the catalog sub-agent. Now, coming to the tools. We did talk about the tool, right? But what tools? The different tools that we have here is the get albums by artist. That means it performs a search on the artist's name using the SQL like function. So in SQL, you have the like function. So you use that to perform the artist search. So I remember seeing this when I looked through the code base. Now, the next one is the get tracks by artist. You pass the information about the artist and you get the tracks made by the artist. The next one is you pass a genre, you get the songs by that. You pass a song title, you get the songs based similar to the title. So up to 10 matches. And then you get the track details given the track ID. So all of these five are the different tools that the music catalog sub-agent can trigger. And the node music assistant performs the tool trigger. The node music tool node performs the um, perform the tool trigger. So the first one chooses the trigger, the next one implements. Sorry, the first one chooses the tool, the second one implements the tool. All right. So this is completely hand built. This is not something off the shelf. These are just Python functions created by us in order to do this. But it's quite simple as well because they are kept as individual functions. Now, the next one is the invoice information sub-agent. Okay, wait. Before going into that, we have uh, Niyati, are you
Yes.
pitching in right now?
Yes.
Yes, please.
Yeah.
Yeah.
So, guys, while we have some more time to cover the topics that Justin has left, because the session is about till 3:30. So, he was getting into multi-agent systems and talking about, sorry, the system design behind it. And we will also cover topic on how to use what we have discussed today. What kind of questions can you expect in interviews, and how to answer them. So we'll take a couple of those examples and go about that. But I'm going to now. So Joseph, sorry, Justin, if you can just let me present, I will just share my screen. I'm replacing your screen as of now, if that's okay.
Yes,
Yes.
please. Yeah.
Awesome. Thanks. Thanks. So, we are just taking a break from just a small few minutes break till the time Justin just goes ahead and maybe wants to answer a few questions in the Q&A section. But we are also taking a break to answer a couple of questions that were asked in the beginning of the session. Is that if I want a structured way to go about my AI upskilling, how can I do that? And I'm just going to take about the next 10 minutes, and then we'll segue into the second half of the session and I'll give it back to Justin. Right. So let's first hear it from Ryan Wales, who's our co-founder. And most of you will relate to a lot of what he's saying, specifically if you're very, very serious about adding the AI layer to your current tech stack. Okay, so hear him out.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one-size-fits-all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up-level to building a fabulous AI career.
Yeah. So I'm just going to echo what Ryan just explained. A lot of you are here to, like, your first short-term goal is in the next 2 days, today and tomorrow, with Justin's help. You start to understand the basics of agentic AI, start understanding what is the system design bridge behind it, and then tomorrow get into deep understanding of multi-agent systems. Some of you are asking if we are going to show practical steps of how it is actually deployed. Yes, but it's equally important to understand the concepts behind it, so that when Justin is building it in front of you, you know exactly when he says LangChain or LangGraph, the use of it, an MCP, what does he mean and why is he using it over there? So, but if you want to have a long-term impact on your career, and if you're a tech professional with at least 5 years of experience, we generally get learners with more than 8 years of experience. So all of them are senior folks who cannot start from scratch. And if you're looking to add that layer of agentic AI on top of your current tech stack, then this is what I'm going to speak in the next 5-7 minutes is going to be extremely important for you. A lot of us can be in any of these four boxes when we are looking at AI upskilling as a as something that we want to achieve, right? It is so some people may feel that AI is moving too fast. I don't know where to start. And I also saw that in the responses that you guys gave in the poll, the first poll that I launched. Some of you also feel that there is too much out there. There are free courses, there is YouTube videos, there are these structured programs, for example, at IK. What do you start? Where do you start? Then you may feel that your job is way too unique for it to be touched by AI. Now that is something I think in 2026 nobody's thinking like that, because every job can be amplified with the help of AI. And some of you, because you are senior, you may feel that AI have to down level or start from scratch, which is not the case. That's the beauty of actually learning or climbing that curve of AI. And I'll tell you how to do that. See, about a couple of years ago, when this all of this started, we were using LLMs and copilots primarily to increase our own productivity. So, for example, if you're a coder, you'll get your codes reviewed by AI, or you'll help in rephrasing. For example, for somebody, it could be as simple as rephrasing emails written to each other, or some have co-pilots that can help you increase your productivity. But now the world is completely changed. We are in 2026, where people, it's all about interviews have become about agentic AI. Job descriptions have AI, agentic AI, Gen AI written all over it, right? So if you are not part of this upskilling curve, it becomes a little difficult to stay relevant in the long term, right? And this is not something to, I'm not trying to scare you. I'm just trying to share what I keep hearing from hiring partners. And I mean, it's also out there, right? If you go to LinkedIn and you check out number of job descriptions for the role that you're trying to apply, there are going to be presence of generative AI, agentic AI across, right? Tools, architecture, everything. And hence you need to defend that in interviews and be able to show practical build level skills, right? So if you are trying to, for example, you have a certain domain. Let's take product manager, or let's take a technical program manager or an EM. If you want to add a layer of complex AI agents and generative AI apps, then you want to basically become AI enabled in your current domain, which is the baseline for everything now. For example, if I am a backend software engineer, my aim in the next few months should be to become AI enabled backend engineer. Okay, and most of you I know would relate to it, but hang on and hear me out and see if this is relevant for you or not. The second and the third is, you are interested in transitioning into more AI intensive roles or ML based roles, right? So you want to become from a software engineer to a machine learning engineer. Now there are courses for that also that we have, and I'll take you through them. There is one course which is, if you don't know where to start, if you want beginner level to advanced level of knowledge in terms of understanding everything about AI for your domain. Because I said in the beginning, and I'll repeat that our programs are built and customized for 18 different domains. That means we do not treat a software engineer as same as a data scientist or an SRE DevOps professional. They are all different. They all have different tracks of AI, and I'll show you the tracks that we cover. So transformative Gen AI and agentic AI will take you from scratch. But if you are already at a certain level where you are already dabbling into building certain, I saw some comments that somebody had shared a GitHub a link of theirs where they had built something and built an AI agent. So if you're there, if you've dabbled into RAG, building an AI agent, and now you need to build a core portfolio of just AI projects, but they need to be industry relevant AI projects, then this program, which we offer with PwC India, is what is relevant for you. We cover four practical industry based projects where the use cases and case studies are given by PwC India. And we cover that in different sectors like BFSI, e-commerce, supply chain management, and healthcare. So you have four projects, and it's for 12 weeks that you can build. So it's very, very portfolio specific, very build specific. This is meant for people who are highly efficient in coding already. If you have a no code background, for example, you're a product manager, don't know coding, and or if you are a say like a data analyst who has some level, or TPM who has some level of coding knowledge but not too much, then we have low code version for you. And if you are highly proficient in coding, then we have pro code version for you in the middle program that I'm showcasing, which is the transformative Gen AI and agentic AI program. Okay, so choose that. So you get three versions. You can choose pro code, low code, or no code in that. But if you want to build complex machine learning models, okay, and you want to transition from, say, a software engineer to a machine learning engineer, or you want to become from a data engineer to a machine learning data engineer, or from you want to learn LLM ops, right? All of that is covered in our flagship machine learning and interview lab program. Okay. We can discuss in the interest of time. I'm not going to get in detail, more detail of each of these three programs. You can talk to our program advisor. I'm going to post the calendar link through which you can book the calls with us at your own convenience. His name is Atif, and he's going to take you through everything that you need to know and specifically personalize the output for you. Then I was talking about the 18 domains that we cover. These are the 18 domains that we cover. And when I say we cover, we have separate projects for you guys. We divide you, especially if you join the transformative Gen AI and agentic AI program, we divide you into pro code, low code, no code tracks further, so that conceptually you cover everything the same, but the way you do it is different. For example, a no code learner would use tools like Na10, Make, Zapier to cover the same concepts that we will be covering in the pro code version. It's just that the tech stack would be different. Okay, so we keep that also in mind. So these are the different, if and you fall into any of these domains, please talk to us. We can take it forward and help you out. We also provide interview preparation. Somebody in the comments today asked that, how are you providing outcomes? We focus a lot on interview preparation. Interview Kickstart actually started by providing domain specific interview preparation for to technical professionals like yourself. And what do we do in that? We cover live DSA and system design concepts. DSA, I know a lot of you may feel that it's basics. Believe me, a lot of professionals come to us and go like, I am crossing the AI rounds, but I am not able to successfully pass the DSA rounds or the system design rounds, right? They are basics. So we even touch upon those basics. Then we also get into domain specific modules. So for example, for a front end engineer, I will have different domain based interview modules compared to an engineering manager who's more like a people leader, plus he or she needs to have engineering reasoning also, right? Other services that we provide in interview preparation are 15 personalized mock interviews with instructors like Justin. So you, for 1 hour, you are in an actual mock interview, and people like Justin are actually, by the way, hiring managers in their own companies. So they hire people like you, or their peers hire people like you. So they know exactly what to ask, and they give you verbal and written feedback, and you have 15 opportunities to actually perfect your interview preparation. And so when you're sitting in an actual interview, it doesn't seem like you're doing it for the first time, or you know exactly what's going to come up. And this we are doing for almost 12 years. So believe me, we have improved this, improvised, and we are every time we are bringing the best version out to you. Thanks to our hiring partners that we keep talking to, and keep improving our programs also. We also help you optimize your resume, not just your resume, but your LinkedIn also, because that's also very important to optimize. We help you with salary negotiations, with behavioral rounds to crack those specific rounds, because these are all part of these 6, 7 rounds are all part of the interviews that you're giving in top tier tech companies, and even startups, for example, like Zomato or Razorpay, etc. We have about a network of about 200 hiring partners, uh, with whom we keep sharing referrals and our learner profiles whenever somebody successfully completes the program. Now, this is the on the right hand side are the timelines. 12, for example, the PwC program on Agentic AI Acceleration and Interview Lab is about 12 weeks of build and 3 months of interview preparation. Similarly, the transformative Gen AI and Agentic AI and Interview Lab is for 3 plus 3 months. 3 months again is the interview preparation part, and ML program also is 6 plus 4 months. If you're unsure, I've written over here, if you're unsure, start here. Add that, become an AI enabled, whatever professional you are, that is where bulk of the jobs are. If you are planning to start here to build a portfolio directly, because so many of you were interested in building, and we are going to get into that in this session. You need intermediate Python knowledge as well as intermediate AI knowledge. What is it? How is it? Like I said, I'll post the link of my program expert. Talk to him, and you can figure out where exactly you are in your current journey and which is the program that fits you. In terms of pricing, this is the pricing that you can see in front of you. The PwC Agentic AI Accelerator and Interview Lab is between 2 to 2.8. Why is that range? Because we, like I said, we customize it for different domains. The pricing is also for specific domains. The transformative Gen AI and Agentic AI plus Interview Lab starts at 1.5 for a particular domain, goes up till 2.8 lakhs. Okay. Flagship ML and Interview Lab is for 3 lakhs, and this has some offers going on at this point of time. As of now, we are running a couple of scholarships in some of these programs. You can check with your program advisor. They will call you anyway after the session. Some of these programs also have a 50% refund policy. And what is that policy? What are the details? We can take that offline for you and answer that. We understand you have responsibilities, other expenses. So all of this can be broken down into EMIs. And believe me, the average salary hike that people have seen post the program, and when they have genuinely completed all the mock interviews, all the modules, everything, the results that they have seen, this cost seems like an investment more than an expense, right? So we can take you through that details also post the session if you are interested. I'm going to launch a poll now to understand if you how serious you are about pursuing a structured program, because most of you mentioned that as a blocker of I don't have a structured roadmap to follow to actually become AI enabled. So here's the help that we can provide. So I'm going to launch a poll, and I would request you guys to let me know if we can directly get in touch with you to take you through a customized roadmap. Okay, we are going to discuss all program details in that call. So yes, and I'm going to hand it over to Justin. I know everybody is, waiting for you to start the second session. So over to you, Justin, and I'm just going to launch the poll.
Okay, give me a moment. All right. So we just finished talking about the first agent, the music catalog sub-agent. So we talked about the supervisor agent, the music catalog sub-agent, and now we are going to talk about the invoice information sub-agent. So yes, we will talk about these agents, and I'll also mention the different nodes that we have, because this agent has access to certain other tools, and we will talk about that as well. All right. So starting with the invoice information sub-agent. So we are using the LangGraph's inbuilt function, which is the create React agent, which is to create a reasoning action agent. Now, in the create React agent, we need to provide what LLM are we using? We need to provide what tools are we providing to the agent. And we have other schema as well that we can provide. Now, the LLM, like we told earlier, it is the OpenAI GPT-4 or Mini that we are using. The tools that we have are the ones on the right side that you can see here. And the first tool is get the invoices by customer sorted by date based on the customer ID. So when you pass a customer ID, all the invoices for that customer will be provided back to you, sorted by the date. And then um, get invoice lines item sorted by price if you give a customer ID. So all the purchased tracks across the invoices sorted by unit price in a descending fashion is given to you. And next one is get the employee by invoice and customer. You need to provide the invoice ID and the customer ID. So find a support representative linked to the specific invoice. That is what this function does. And finally, get invoice line items, provided that you're providing the invoice ID and the customer ID. So this provides the full track details for one specific invoice. So these are the four functions that provides information about invoices, which is why our agent's name is invoice information sub-agent. Now, here you can see that in this, here, 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 in all of this, customer ID is a required parameter. And this is not extracted from what the user types. This customer ID is extracted from the system message. That means a user is interacting with the system. I did tell that the user has to validate with their customer ID in the first place. And that customer ID, which is used to validate, is used for all of this. And this customer ID or this one or this one or this one is not provided by the user, but this is provided as a system message. Because if I'm the customer, if I type that, okay, if I say that the customer ID is 52, and if I'm customer ID 3, I say that customer ID is 52 and fetch the information, then if it goes and fetches it, it is a security issue because I shouldn't have access to customer ID 52 or the information about that. So we do not want any such issues, which is why the customer ID is injected via a system message and not from the customer directly. So the customer authenticates with their customer ID in the first place, and only that customer ID is used for the rest of the scenario. So the graph puts it in this function for identity verification. So a malicious user cannot simply go and look for another user's invoices, for instance. Just wanted to mention that. Now, all right. Uh, when you talk about a LangChain tool, all of the tools that we have, all of the 9 tools, the 5 tools in the first agent, the 4 tools in the second agent, all of our 9 tools follow the same pattern. And this pattern involves a tool decorator. The tool decorator is what tells LangChain that this is a tool that the agent should be using. So the LLM will be able to see the name of the function. The LLM will be able to see the doc string that is provided. Doc string is when you provide a Python function, you can also have a comment or a doc string provided to the function saying that this is what the function is responsible for. So that string or that comment can be seen by the LLM along with the function name. And also the parameters required for that function. All of these 3 things can be seen by the LLM. And now the LLM knows what tools are available, the LLM knows what the tools do, and the LLM also knows what the tools expect as an input. So um, the name, the doc string, and the typed parameters. And this will be the tool spec. That means the specifications of the tool. Now, that doc string which I was mentioning is the description of the tool. So that is a string that you provide. So whenever you write a tool is like a function. Whenever you write a tool in any of the agentic system applications, you need to ensure that the description of that function is properly provided as a doc string, because only then the LLM will understand what this function is capable of doing. It does not go through the code of the function. It goes through just the doc string. So here in this example, wait, do we have an example here? Wait, one moment. I have an example here in the code. Mm, If we take one of those tools, mm, wait, um, okay, okay. So let's look at one of the tools here. Get albums by artist. So in this tool that we have here, the LLM will not be able to see the complete tool. The LLM will be able to see the name of the tool, get artists, get albums by artist. And the LLM knows that this is a tool because we are using the tool decorator here. Now, the LLM also knows that it requires an input, which is artist. And this should be of the format string. This much information is given to the LLM. That means the LLM now knows that there is a tool called get albums by artist, which takes in a string, which is the name of the album. And now the LLM also knows what this function does, not because it goes through the code, but because it has access to this doc string. This is the doc string that I was talking about. So this gives the information as to what this tool is capable of, which is to get albums by an artist from the music catalog, uses fuzzy matching on artist name. So if the requirement is to get an artist from the music catalog, sorry, get the albums by an artist from the music catalog, then this is a function that the LLM should trigger, or this is the tool that the LLM should trigger. So providing a proper description or a doc string is on us, the people who have created this. So it's very imperative, very important that we create a good one. Otherwise, if it is confusing or if it is not properly structured or if it is not properly uh, provided, then the LLM will also be confused. All right, just wanted to mention that part. Mm. Now, the tool decorator, and this is the doc string I did mention about the tool description. Now, coming to the next part here, in the tools where you do a fuzzy match, you have the uh, pattern matching. Now, for instance, when you do this pattern percentage AC slash DC percentage, it is going to look for any string that contains AC slash DC. That means it looks for any AC DC what do you say tracks. Now, this is partial queries, and the idea is that see, the user might say, show me Beatles albums. The actual name of the band or the artist is the Beatles. But we need to actually look for the Beatles, only then we can find those songs by the Beatles. The problem is user might just say Beatles. Now, you need to perform a partial match. Only then you will only then your system can fetch the songs by Beatles. So Beatles is what the user asks, and then the actual name is the Beatles. So if you perform a partial match with this, then you will also come up with the songs given by or rendered by the Beatles. So which is why this partial matching is very important. And this partial matching is what we use in almost all of these tools to perform the matching in the SQL DB. Now, the next one. Also, another thing is when you use this, it also ensures that SQL injection is prevented. That means the user cannot directly inject a SQL query um, into the DB. So the SQL injection is also prevented. Now, the empty check. So if a query returns nothing, then rather than giving nothing to the user, we replace it with a friendly message. Something like no albums found as per your request or no requirements matching your criteria, something like that. And then finally, the JSON string return, everything is returned in the format of JSON. So the LLM parses and formats them for the customer in such a way that the LLM can give a proper sentence back to the customer. But every tool provides the output in the format of a proper JSON. So, um, all right. So the tool anatomy is simply the tool decorator is there, the doc string is there, the partial matching is there wherever SQL DB matching is required. Then, if it returns an empty message, then the agent can return a placeholder instead of an empty message. And then um, all of the tools are responsible for providing output in the format of a JSON string to ensure that it is consistent and the LLM can take that structured output and then create free flowing sentences from it and give it back to the user. because the LLM's responsibility is to converse with the user. It should not give a JSON output or a list output or anything like that. It should take that JSON string, understand what it is. So, for instance, the output looks like Michael Jackson, colon, the thriller, so and so. And then the LLM should take that and then restructure it, saying that, okay, Michael Jackson has composed these songs which are available in our database. So, in this way, the LLM should restructure the response and give it back properly to the user. All right. And the next part is the identity verification. So, I did mention about the identity verification, which is the first part in our workflow before the supervisor agent takes over, which is the verify info node. And this verify info node is actually quite simple. From the user's input, we are asking the LLM to extract one identifier, and this identifier can be customer ID, phone number, or an email address. Phone number, email ID, or customer ID. So, if it is a numeric string, then it's a customer ID. If it is a if it contains the at the rate, then it is an email. If it contains the plus or the country code or something like that, then it's a phone number. Now, first thing, the LLM will figure out which of these could be the phone number or email address or customer ID. Then, whatever the LLM has pulled from the user's input, that is passed to either the normalized font function or converting to lowercase if it is an email ID, or passing it to or converting it to a numerical format, which if it is a customer ID. Now, this is what these functions are capable of doing. And once the identifier is found, then whatever this customer identifier is, we are going to take that customer ID, and the downstream agents, starting from the supervisor agent, are going to use that customer ID for the rest of the tasks. If you remember in the previous slides, we saw that these functions, all of these takes customer ID, and that customer ID is given by the user in the first place here, which is validated and then passed to the further tools wherever required. So that means it becomes a part of the system message, which can be extracted whenever required. Now, there is also a human in the loop. The human in the loop comes into the picture when, for instance, the verification fails. If you remember the flowchart at the start, the flowchart at the start showed that the verification happens two ways. Either the verification succeeds or the interrupt should come into the picture. And it should wait for the graphs should pause completely and the graph should wait for the user's input, which is the correct customer ID. That means the line graph is going to save the current state into a memory saver checkpointer, and the Gradeo UI detects the pause by checking the snapshot dot next. The idea is that the Gradeo UI checks whether the verification is complete. If not, it will just wait and it will show a status waiting for your input. That means if the customer ID did not succeed, then it will just wait for the customer's input for the correct customer ID. So the user types their credentials into the chat, and then the human message is taken back to the verify info node, and the verify info tries to verify it again. So it performs an iterative process. That means if the customer, at the start, there is an interrupt triggered, and then the user is asked to input the customer ID. User inputs the customer ID, and then that is verified by the verify info function. If it fails, then the same thing will happen again. So the idea is very simple. Interrupt comes into the picture when humans have to provide an input, mandatory input. So that is what interrupt is about. Now, coming to the memory system, there are two layers. One is the current conversation memory, and that is short-term memory. And then there is a long-term memory which carries the preference. So when you look at the conversation memory, it is about the conversation messages within a session. I'm having a conversation with the chatbot. So for this particular session, it is going to store this information or the memory so that it can pull up the current conversation, and based on that, it can respond. Remember, LLMs are stateless. So we need to provide the additional memory. Well, that is what we are doing here. Now, this enables multi-turn conversations. That means back and forth conversations are enabled using this. And then this is used as a checkpointer in all of the compiled subagents. So all of the compiled subagents contribute to the conversation memory whenever they are used. Now, every time you restart the session or every time you restart the server, the conversation memory is wiped off. Now, this is the disadvantage, or this is a design feature, I would say, of the conversation memory, because you don't want to retain the conversation memory for days or months or anything. Now, on the other hand, you have the in-memory store, which is the preference memory, which we call it as the persistent memory. That means if I'm user number 57, I say that I'm interested in rock music. That means this music preference should be identified and should be saved for long term. And this will be added as user memory. Now, only the explicitly mentioned preferences are saved. The questions are not saved. Browsing history is not saved, or anything external is not saved. Only the user's explicitly mentioned preferences are saved. And the new preferences are added in, and the existing preferences are never removed. So I like rock music, that is added. I like classical music, that is also added. So the existing preferences are not removed. Only the new preferences are kept on being added. All right. Now, when you actually go into production, I'll tell you what happens. So, in a production system, your in memory store would be replaced with Redis. Usually, in production systems, we usually have Redis for in memory store and the memory saver here. Instead of that, we generally use SQLite saver or Postgre saver in production systems because we need to persist information even after session restarts. And in production systems, we generally use Redis for the preference memory, and we generally use SQLite server or Postgre server for conversation memory. And tomorrow's session, we'll look at this part in detail. All right. Now coming to the, yeah, I see some questions that are there. Yes, I think I can take up some questions from the attendees. I see some hands that are raised. Jitendra, hi. If you're there. All right. Or was it an accident? I'm not sure. Mohit and Vivek, if you have questions, I can take it. I see your raised hands. Otherwise, I can take up some questions in the Q&A. No worries. One moment. Can you please increase the size of the slide? Apologies for that. Should work. Can you see it now? Better? Okay. One moment. Perfect. You're welcome. Then in the Q&A, okay, all of these questions are asked. Thank you very much, Abhinav, for answering these questions on time. I see a lot of questions that were asked and answered by Abhinav. Thank you very much. Uh, so in memory means it is cache. Yes. Yeah. All right. So Kashif, if you are in cybersecurity, so even in cybersecurity, one of the agentic systems that I've seen recently was something which is to in cybersecurity. One moment, I forgot the name of those tools. So there are specific tools that people use to query whether certain IP addresses are safe, whether certain websites are secure, etc. So when you use those tools, I forgot the name of those tools. I can pull that up if I want, but give me a moment. So um, in cybersecurity, I've seen agentic systems or customer service chatbots that can significantly utilize those tools in order to provide cybersecurity related um, conversations with users depending on the depending on the products that you're providing. So I've predominantly seen agentic systems in cybersecurity area where people where users are given responses based on the required cybersecurity use cases, like for example checking whether certain websites are safe or not, checking whether certain tools are um, tools are working as expected or not, whether they have security vulnerabilities or not. So multi-agent systems have been in use in cybersecurity as well as in finance, as well as in banking, etc. Right. All right. Let's get back to business. So one moment. Give me a moment, please. Yeah. Yeah. Apologies about that. Yeah. Let's continue. One moment. Let me just. Yes. So to spin up these agents, so I have already spun it up here in the Hugging Face spaces. So Hugging Face spaces were used to deploy this. So if you're asking me to create this agent in front of you, you are just asking me to type out this Python functions. So creating the agent is just like a Python code. It is just a Python function or a Python code that you're creating and you are deploying it. So, and like I told you, these are the Python functions that we use for this tools or the agentic systems, and we are deployed it here. And the deployed endpoint is what you're seeing right now. And this is the conversation that I'm currently having with it. So what I just wanted to show you is that there are multiple agents, and if you want to use those agents, the decision of what agent to be used is by the supervisor agent. You will not see, the end user will not see what happens under the hood. The end user will not see the multiple agents. The end user will only see the conversation that they're having with the agentic system. So here, when I asked the question, what rock albums do you have? It gave me a list of rock tracks. 10 rock songs. So this is, if I remember right, there was a function called get albums by genre or something like that. That was triggered under the hood, which the end user did not see. It's fine. The end user should not see any of this, but the end user should only get the response. So now you might ask me, why do we write all of these functions then? We need to write all of these functions because we do not want the large language model or the chat GPT to just tell me 10 rock music names, but rather I want the agentic system to fetch from the database 10 rock songs that it has access to. All right. So, or the 10 rock albums that it has access to. So, which is why it needs to go to our database, fetch information from that, and then populate it here. So, how was that? How did that happen? I asked the question, what rock albums do you have? The supervisor agent took it. The supervisor agent passed it to the first agent. What was the name of that? The music catalog agent. Yes, the music catalog agent. Within it, triggered the tool, which is to fetch the albums based on the genre. And then that tool provided 10 responses and along with other information. And that information is taken by the LLM and then converted it to a human readable format, which is a proper, not a JSON file, but rather a proper string, and then given it back to me. So all of these things happened when I just asked the question, what rock albums do you have? So this is to answer the question when you asked what happens under the hood, how does these agentic systems work? All right. Okay, let's continue. So we were talking about the different two kinds of memory that we had. And another thing was the pydentic models. So the requirement of pydentic models is that for any tool call, for any function call, we need to validate whether the output is in the expected format, whether the output is in the structure that we expect. And that is where we use pydentic. So in here, we use two pydentic models. So one moment. All right. So one instance, this verify info function that we have, this verify info function is forced to return one identifier field. So we ask the LLM to look at the user's input. And then we ask the LLM to return one identifier field. And this identifier field can be email or phone number or customer ID. Or it can also be none if none of these are found. Now, the verify info uses the user input pydantic model. That's a pydantic model that we created just to ensure that it returns one identifier field. Now, similarly, when we use the create memory function, the create memory function uses the user profile pydantic model. And this asks the LLM to extract explicit music preferences from the conversation. And then this music preference is merged with the existing profile. Like, for example, I type in something like, I like rock music, or I prefer pop music, or something like that. Then the create memory mandates the LLM to pick explicit music preferences like rock or pop that I just mentioned from the conversation, and then it adds to the existing user profile. That means the user prefers this, or the user likes this, the user has explicitly stated this, so add it to the user profile. So the user profile consists of the customer ID and the list of music preferences. Example, rock, AC/DC, jazz, etc. Now the user input consists of the user identifier, and it could be either an ID or an email or a phone number or none. All right. So these are the two pydantic models. We call it models, but they are actually, you can consider it like schema, which is used to validate, which is used to ensure that the output is in the required format that we want, or the extraction is following a certain schema that we want. All right. Now, we also have a function with structured output, where this is a LangChain method that forces the LLM to respond with the JSON matching a certain specific schema. No free text, no gibberish, no hallucination, but specific schema-based response. All right. Yeah, just wanted to mention the fact that we use certain schema enablers, or the schema, certain mechanism that mandates a specific schema or mandates a specific way of response for the different functions or for the different extractions. And we are using Pydantic as the data validation library in order to do this for us. So Pydantic, so if you have Pydantic, it will be quite easy to do this for us. One moment, I can show you this in the code as well. Um, the user input, one moment. uh yep, here. So these two are the pydantic models. So you have the user input and you have the user profile. So this is what I mentioned. So the user input, in the user input, we specifically mentioned that the identifier that is extracted can be a customer ID, either numeric or an email address, which contains at the rate, or a phone number that starts either with a plus or contains digits. And it says return an empty string if no identifier is found in the message. And this mandate is linked with the verify info function. And when the verify info function is triggered, this mandate ensures that the LLM returns only something as per our requirement here. And similarly, the user profile asks to find the music preferences of the customer, like for example, artists, genres, or albums that they like. And this is linked with the create memory function. So that means the LLM looks for the preferences of the user, and the preferences of the user are denoted or are enforced by the user profile here, and that is being clubbed with the create memory function. So the pydantic models are used to ensure that the outputs, it's a data validation library. That's what we talk about. That's what we refer to in the pydantic models. So it is just a function call that is happening behind the scenes. Yes, all of these agentic systems that we talk about are function calls happening behind. No, wait. All of these agentic systems that we have use tools, and these tools are deterministic. These tools are not LLMs, or not are not are not using any thinking. These are tools, but we have LLMs that decides which tool to be triggered, or if any tool has to be triggered in the first place. So if you ask, are agentic systems intelligent? Yes, because they use LLMs. Are they always using intelligence? Not necessarily. Once the LLM decides what tool to be triggered, the triggering of that tool need not be intelligent. Right? For instance, you asked ChatGPT, should I carry an umbrella today in Bangalore? And ChatGPT cannot answer that directly because it needs the weather information. So ChatGPT triggers the weather API. Triggering the weather API is a tool. Once the weather API is triggered, there is no intelligence there. Weather API just takes the location and the date, gives back the weather today. And then once again, the LLM comes into the picture, looks at the response, and decides what to go do next. All right. So, Barka, to answer your question, agentic systems are not just function calling. Agentic systems are intelligent. The tool parts are not intelligent. I understand. But the LLM decides what tool to be triggered, when, and also if any tool has to be triggered. And this is a very simple use case that we are seeing here. The actual use cases consist of multiple tools, multiple databases, multiple agents, handing off information to each other, calling the required tools, gathering information, performing planning, performing you know a response curation, and all of it. Finally, the end user will see the final response which is created using all of this. Okay. Darshit, to explain the flow, the high level flow, I think we had explained the high level flow a while back. One moment. Yeah, I can give a recap on that nowadays. This was the flow. So at the start, you start with verifying the information, which is the customer ID, email, or phone number. And then if the information verification has succeeded, then the user's memory is loaded. That means the user's past preferences are loaded. And once the user's preferences are loaded, then the supervisor comes into the picture. The supervisor looks at the user's query and then tries to address it. In order to address that, the supervisor can either call the music catalog subagent, which fetches information from the DB, or it can also create the information subagent, invoice information subagent, which is to fetch information about the past invoices, purchases, billings of the customer. Or it can also identify additional memory preferences of the user. Like, for example, if the user has mentioned something like, I prefer rock songs, then that is identified and added to the memory. So the supervisor is capable of doing these three things. There are three agents here. The supervisor agent being the first agent, deciding which sub-agent to be triggered. Then the music catalog sub-agent being your next agent, and the invoice information sub-agent being your third agent. Now, these are the agents. Now, within these agents that you have, there are some tools or functions as well. Now, the music catalog sub-agent has 5 tools, if I remember right. And the invoice information sub-agent has 4 tools, if I remember right. Now, apart from this, there are functions, like, for example, the verify info function that you have here, the human input function that you have here. Then verify info, if it doesn't succeed, it goes to the human input. The human is expected to give the customer ID or the email ID or the phone number, and that is the role of the human input. And then you have load memory function, loading the past list of preferences of the user. Then the supervisor is an agent. The music catalog sub agent is an agent. When I talk about an agent, it can be a function. Inside the function, we will use an LLM. So that is why the supervisor is a node. The music catalog subagent is also a node. The invoice information subagent is also a node. Create memory is also a node. But the supervisor, music catalog, and invoice information are agents, right? So wherever it uses reasoning, wherever it uses LLMs, along with the access to tools, we call it agents, along with memory, obviously. Let's head back. Thanks for answering the questions, by the way. So when they come up, let's get to our business. All right. So we were talking about the pydantic models enforcing the required. Yeah, thank you very much. So we were talking about the pydantic models enforcing the required LLM output structure. So this is a data validation library. Pydantic is the most popular data validation library out there. All right. Now the next part, the prompt engineering. So for all of this, for ensuring that the LLMs behave the way that we expect them to behave, we need proper detailed prompts. And now coming to the prompt engineering part. All right. So a well-engineered prompt is the difference between a system that works reliably and the one that occasionally makes mistakes versus the one that always makes mistakes. So you can have LLMs, you can have tools, you can have databases, anything, but proper prompting is very important. Even the chat GPT that you use, which is an agentic system, has a lot of system prompt deep inside, which you or me will never see. Right now, coming to the first, anti-hallucination, which is grounding rules, ensuring that the responses from the agentic systems are tied to the what do you say, are tied um, to our database. That means it doesn't come up with anything on its own. Now, hallucination means the LLM fabricating plausible sounding information but incorrect response. So the LLM might say something like, okay, um, I remember back in 2022, if you ask ChatGPT something like what is one plus three, it might say that it is two. Okay, or if you give it a detailed calculation to perform, it might make mistakes in between, and that is hallucination. So we need to prevent hallucination. So the best way to prevent hallucination for such scenario, like for example, one plus three, is to ensure that you use a calculator under the hood to provide the response rather than expecting the large language model to perform conversation and you expecting that conversation to be accurate from a mathematical perspective. So as far as my understanding goes, it uses calculators under the hood, but knowing what calculator and when to trigger, that is the capability of the LLM, just like the tools that we had here. All right. Now, in our use case, hallucination can be incorrect prices of the albums, incorrect artist names, incorrect invoice numbers. All of this can be an issue. Now, we need to ensure that these responses are grounded based on our database. That means we are ensuring that the responses are provided only based on tools. That means only provide information returned by the tools. Never infer, never assume, or never extrapolate beyond what the tools provide. The tools, for instance, provides the information about the invoice. Tools, for instance, provide information about the artist. So we are explicitly asking the large language model to provide responses only based on what the tools returned, not based on what it is aware of already. Now, exact quoting. Always quote the exact numbers from the tool results. Never round up the numbers, never estimate or never approximate the numbers. So this is also a prompt that is used to ensure that it does not hallucinate. Now, the honest failures. If a tool returns empty results, say that I could not find that in our catalog, or I could not find that in our list of invoices or whatever it is. And do not try to answer from anything that the LLM might know beforehand. Now, the scope boundaries. If the query is outside the agent's tools, explicitly say that and defer to the right team. So it simply means that if the query is outside what the tools can answer, just say that it doesn't know. Do not try to answer from the data using which the LLM was trained in the first place. I told you that we are always using an external LLM. It can be OpenAI's LLM, it can be open source LLMs, anything. So we are explicitly asking it to not answer from the training of the LLM. Now the next one, no memory based answers. So always call a tool before answering. That means there is always a chance that the LLM was trained on rock music, ACDC, pop, etc. Now, we do not want the LLM to answer based on that. We just want the LLM to make intelligent reasoning based on the conversational capability that it has been imparted during the process of training. Then the last one is the truncation transparency. For instance, if it gives only 10 results, it should say that it is limiting itself to 10 results. One moment. Yeah. So here, it explicitly told that we have a total of 1,309 tracks. And here are some examples. So that means it's explicitly saying that this is not all of them that it has. So this is what the truncation transparency is about. Being transparent that this is not everything that it has got, but here you go, some of them. All right. So these are the anti-hallucination grounding rules that we have provided as prompts. Prompt means text that we have provided so that the LLM knows how to behave. Now the next one is the music agent prompt. So we'll take a look at the prompt that is used in music agent. So the music agent prompt is dynamically generated at runtime, but it is not completely dynamically generated. So I'll show you the structure. Give me a moment. Or a function. This one. So you can see here that there is this generate music assistant prompt. And this generate music assistant prompt has a set of grounding rules, which we just discussed. Provide only information that the tool has returned and all of this. Now, we are also providing some roles saying that you are the music catalog assistant. You help customer discover and learn about music in the catalog. And then we also tell that these are the tools available for you. That description of the tools is also provided here. Now, we also mention to always call the appropriate tool before answering. Do not answer from memory. Then we also ask it to uh, give exact matches if they are found, or try alternate spellings or partial names. And then we ask it to provide the artist name and album for each song that is responded to. That is responded. So the response format is also mentioned here. And then here you can see that I'm just zooming out a bit because I want you to see it in it completely. So you can see here that we are returning this prompt. This is the prompt, but in this prompt everything is fixed except all of it is fixed except one part, that is this. See, everything else is a string except this one. This is a variable, which is memory. And that is the prior saved user preferences. So the past user preferences are already a part of the prompt, but we cannot manually write it explicitly because for different users, different user preferences. So we are just providing it as a variable, which is the memory here. So we are just saying that the prior saved user preferences are these. That's all. So just wanted to show the prompt for the um, a sample prompt. Just wanted to show the sample prompt for the music assistant. So this is generally known as F string, by the way. In Python, you can give a string using double quotes, but if you want to inject variables into the string, you should give it a F at the starting. And that is the meaning of this. So if you want to explicitly mention that something is a variable, use curly brackets inside the F string. That's all. So everything else, the string remains the same, except that instead of this memory here, the actual value of the memory variable is plugged here. And that is a list, if I remember right, consisting of the past user preferences or the prior saved user preferences. That's the right way to put it. All right. Now, this is the F string injection that I just showed you right now. Then the section headers. If you remember the section headers, see search guidelines, response format, grounding rules, etc. So you do not have to follow this exact same format. This is just used for so that the LLM can understand the different aspects separately. Now, numbered roles. Each of the roles are numbered explicitly. And also all the list of tools are provided in the prompt so that there is no confusion for the LLM as to what tools it has access to. All right. Now, coming to the end-to-end request lifecycle. Yeah. I think we already saw that in the flowchart, pretty much the same thing. So starting with the user typing a message in the Gradeo UI and typing send. And then the show user message. Okay, so the show user message takes the user message and appends it to the chat history. And the status shows us processing. The next step, if it is a new session started by the user, then a thread ID is generated. A thread ID, this one randomly generates a now, this one is important because using this unique identifier, a session is identified. Now, in order to keep a track of the current conversation in the session, we will update the current memory um, or the what do you say, short-term memory with the conversation that's coming in for this particular session. So if multiple users are using this application parallelly, you should not confuse with the conversation history of multiple people, or you should not take the current dialogue given by user B and append it to user A's conversation history. So you have to keep it separate. And that separation is taken care by the session ID. And then step 3, a human message is created and the graph.stream is called. The idea is that the graph starts streaming the node outputs when the user provides an input. Now, the graph starts with entering the verify info node, checks whether there is a customer ID. If the customer ID is already there from a previous turn, then pass through it. If no, then go back to verification of the customer ID. And that is the step 5. Wait. Uh, yeah, that is a step 5. So if there is no ID provided, the LLM is expected to extract the identifier from the user's response. So the user input plus the extraction prompt. The extraction prompt is a set of prompts given to extract the information from the what do you say the customer ID or the email ID or phone number from the user's response. Now it returns something like an identifier as file or an identifier as this email ID or the phone number, or it returns an empty string. All right. Now the next one is, once the customer ID is retrieved, the database is looked up using the customer ID, and then ID or email or phone number is used to look that up. Now, once the database is looked up, the customer is what do you say pinpointed to, and then the memory belonging to the customer is retrieved using the load memory function. Now, it retrieves any saved preferences, rock music, pop, any of these. Now, the next one is the supervisor routing the query. So once the memory is loaded, the user types in the next query. Now, the supervisor is taking the query from the user and the LLM comes into the picture. The LLM takes the supervisor prompt and then decides whether to go for a music catalog subagent or to go for the invoice information subagent or to add a new preference to the existing preferences. Now, the reasoning action loop executes. Whichever agent is executed, music catalog or invoice subagent, it executes the reasoning action loop. The corresponding tools are called, the response of the tool is observed, and this tool calling or different tool callings are repeated until all the required information um, is extracted, and then the LLM responds. So the reasoning action, once again, let me repeat what I said earlier. It is like a while loop where you have the LLM deciding what tool to trigger, the tool providing the response, and the LLM looking at the response of the tool, deciding should another tool be triggered, or do I have adequate information to respond to the user. And this loop continues until it has adequate information to respond to the user. Now, yeah. So after the response is created, the create memory extracts any new preferences that was mentioned during this conversation, merges with the existing profile, and then saves it back to the memory store. So the preferences have been updated, if any, and then that is sorted, and this loop or this entire request lifecycle is completed. All right. So this is the complete life cycle. Once again, starting with the identity verification, to going ahead with the supervisor agent, deciding what subagent to be triggered. The subagent, any subagent follows the React approach in our implementation reasoning action, and then this process continues. Oh, sorry. This one. I'm really sorry. I forgot to switch the window. Um, I was looking at the window in my writing pad. Apologies for that. Wait. All right. So we were talking about the end-to-end request lifecycle. I can reiterate this because I forgot to switch the slides. Apologies. Yes, a wrong screen was being shared. Really sorry. Um, Girish, I'm very sorry about that. Thanks, Abhinav, for pointing it out. I didn't see it. Yeah, I'll walk through this again. No worries. Um, for verification, are we only asking music related query? We do not Manoj Kumar, I'm trying to understand your question. For verification, like we are only asking music related query. We do not have to use LLM call, I assume. How do we restrict that? If the user is asking music related query, we need to trigger an LLM related call, because if it is a music related query, then it could be either invoice, regarding the invoice, or regarding the music. Okay, you're talking about the first agent. So even in the first agent, we need to decide what tool to trigger, right? We fetch the artist information? Should we fetch some other information about the song, something like that? So LLM should be used in order to decide what tools to be triggered, and only based on that can it make a decision uh, as to whether the user's question can be answered satisfactorily or not. Now, quick recap on the request lifecycle, because I was on a different tab, my bad. So the request lifecycle is starting with uh, the show user message of Gradeo. That means the user has a provision to type their query into it. Now a new session starts. When a new session starts, this is the unique identifier that I was talking about, to show that this is a new session, or this is a session ID from now on. Now, all right. Now the human message is triggered. That means the human provides the response. Now, based on the human's response, we trigger the verify node. The verify node validates whether the user has provided the customer ID or the email ID or the phone number. Now, based on that, the database is looked up. Wait. And now, based on that, um, yeah, the LLM has to identify what is the unique identifier given, whether it's a customer ID, whether it's a phone number, or an email ID. Or if none of these are identified, it will return an empty string. Now, once the customer ID is retrieved or fetched, we will fetch the memory preferences from the customer ID. That means based on the customer ID, we extract the memory preferences. Now, once that is extracted, then the supervisor's objective is to go through the query, identify whether it has to trigger the invoice subagent or the music catalog subagent. And once the correct subagent is triggered, the reasoning action loop triggers. And in this, you have the different tools. You have the agent calling the tool giving the response, the agent deciding or performing further reasoning, calling another tool, and this goes on until the agent has adequate information to answer the user's query, and then the user's query is answered. Now, in this process, if the user has provided some updated preferences, any new interests explicitly mentioned by the user, then the create memory is triggered and the existing memory is updated with a new preference. Updated, not replaced. That means the user used to like 2, 3 genres of songs. Today, the user said that they also like classical music. Then that should be added to the preferences. For all of this, we need the LLM. From free flowing text, if it needs to understand any of these, we need the LLM. All right. Okay. Just wanted to touch base on the request lifecycle. And yeah, in the Gradeo UI, I'm not going into the UI part a lot. The idea is that it uses a two-phase event chain. I'm not going into the details. The idea is that it's two-phase. The first phase fires when the user's message appears in the chat. So the input is cleared and the status changes to processing. So whenever the user provides any input. So let me try asking something. I don't know the other genres other than what rock albums do you have? One moment. Okay. Let me ask a question. So give some albums composed by Michael Jackson. So the thing is, I don't know whether it has any information about Michael Jackson in the DB, because I did not go through the complete database. So let's ask a question like this. So the moment a question comes into the picture, it says processing here. And that it went by, but still that is given. That is the first part of the Gradeo application. that mentions the two-phase event. I told you about the two-phase event. The first phase is the user's message appears in the chat, input is cleared, and the status changes to processing. That is phase one. And we saw the message just now. So yeah, it says you don't need to verify the identity for browsing music questions. So here are some albums by Michael Jackson. So if I ask any invoice related questions, it will ask me to verify my identity, because only the corresponding users can check their invoices, right? Okay, I did talk about the two-stage part. The first phase is this. The second phase is under the hood, where it performs the LLM calls and the tools are executed and all of this, and we do not see that explicitly, but it happens under the hood. Even now, it actually implemented, it actually ran a function, it actually triggered the music subagent, and the music subagent would have called uh, get albums by artists. And then it fetched me these albums. So all of this happened under the hood, and we do not see it. The end user does not see it. I just wanted to say that this happens under the hood. And then, yeah. So we were talking about the two-phase event and then the interrupt detection. Sorry. The idea about the interrupt detection is that, see, um, after the implementation of the agent, then if um, if it requires some additional information, like for example, customer ID, then the graph is paused using an interrupt. And then it says waiting for your input if it requires a customer ID or something like that. And that change of the status is the interrupt part, which I was talking about. Now, yeah, I'm not going into the other details of the UI because that is not what we are here for. So the general idea is the different threads are isolated using a unique identifier UUID. That means you and me might be using the same application, but we will not face any overlap of the different conversations or anything because we have different session IDs. All right. Then, okay. Um, yeah, the reset conversation creates a new thread ID. The graph.stream implements the graph under the hood, the multi-agent graph under the hood. And then, um, yeah, this is the basic UI that I just wanted to touch base on. And I just wanted to show you the UI endpoint as well. So I will share the endpoint with you. So if you want, you can play around with it here in the chat. So you can type in your queries, you can try to access. So you can try to see whether all of these functions are accessed by, you will not see whether the functions are accessed, but you can ask questions in such a way that these functions may be triggered. So the end user will not be able to see the functions or anything at the end, right? So let me also share the GitHub repo once again with you. Okay. Here. Okay. So just wanted to mention that part. And with this, the request lifecycle, we have concluded the high level architecture or the high level explanation of what happens under this agentic system. And when you ask me build the agent, I just wanted to reiterate the fact that it is just code. It is just software engineering that we are using, unless we are using something like a UI based uh, no code system, like for example, an A10, which we use to build, drag and drop, and build the agentic system. That's a different thing. But that can be called building it live. But this one is you are actually implementing it, and this is a code base, and you are just productionizing it. That's all, and the complete instructions as to how to get this running in your Hugging Face spaces. So you can deploy it in Hugging Face spaces for free, just like this. So you can deploy it by yourself. The complete instructions on how to go ahead with this is given here. So you can just follow the setup. Let's see the complete instructions. You can just follow the setup and you will be good. All right. As the last part of today's session, I think some interview prep is also to be covered. All right. So this is the last part of today's session. Let me just make it quick. First question, why use a multi-agent architecture? The very simple reason is, just like in a movie crew, you have cinematographer, you have the director, you have the music composer, you have the director of photography, etc. The responsibilities are divided and the responsibilities are focused. That is why we have specialized agents with focused responsibilities in a multi-agent architecture. Now, it doesn't mean that one person by themselves cannot create a movie. They can. And that is a single agent architecture. But if you want separation of responsibilities, if you want the single agent not having access to all of the tools, but specific agents are having access to only those tools that it needs, then a multi-agent system is what you should go for. Then also managing the different prompts. Like for example, for each of the agent, you have separate prompts. We saw that earlier. You need a multi-agent system for that. Isolating the tool I just mentioned. And also for scalability, that means you need to scale one agent. You might need to provide a less expensive LLM to another agent. All of this is possible in a multi-agent system. And also from a debugging perspective too, it is much simpler rather than debugging a monolithic architecture consisting of a single agent. Now, um, yeah, that's the answer to why use a multi-agent architecture instead of one single large agent. Now coming to the next question. Wait. Um, One moment. Oh, looks like okay. I have some other questions as well. So I thought this was okay. Anyway, another question that could come up based on this is how does the system prevent hallucination? If you remember, we had specific prompts mandating grounding, saying only provide information returned by the tools, never fabricate information, and all of that, which you saw a moment back as a part of prompt. Yes, that prevents hallucination to a great extent. And also, the agents do not have direct database knowledge. The agents must call the tools will query from the database, give it back to the agents. So the agents cannot mix up different things in the database because it cannot see the database completely. It has to call the tool and the tool will fetch whatever is required and the agents can respond based on that. And next, we also in the prompt, we also mentioned exact number quoting. We also asked it to uh, create parameterized SQL to give outputs in a specific JSON format. And also we asked it to provide uh, what do you say? Even in the instance where it cannot fetch something, we asked it to say that it does not have the response rather than coming up with a hallucinated response. All right. Now, one more question that could be possibly asked is the identity verification flow and the security design. If you remember, when the identity verification triggers, then it verifies whether it's a customer ID, email ID, or phone number. So once the customer ID is identified, then that variable is being used to inject to other functions. So if the user says in the chat that for customer ID 7, what was the last invoice? It will not fetch because the user is customer ID 53. So why should they have access to customer ID 7? So even though they explicitly mentioned the customer ID, the existing customer ID, which is number 53, is used to inject to the tools that use the customer ID as a parameter. So that is a security design that is used in the identity usage. So a person cannot access another person's personal information. So these are some questions that I wanted to cover when I mean, with respect to this implementation. So yeah, I do not have the questions. I do not have the slides for the other two questions. That's why I just kept on this slide itself. So this was the first question, why multi-agent architecture? The second question that I mentioned was how did you ensure the hallucination prevention? The third question was identity verification and the security design. Just wanted to mention that part. Yep. Now, um, how does
Justin,
the
if you
lang
want
graphs
to,
shared?
sorry,
Yep,
Justin, if you
sorry.
want to go through the second one, I think for some reason the slide was hidden. So I can,
That's all.
yeah, yeah, yeah. So if you
Yeah.
want to say there were,
Oh, perfect. The thing is, I knew that there was a slide, but I couldn't see it
yes,
here.
yes,
In my notes, I
there
could
are a
see it.
couple of,
That's why.
correct, correct. There are a
Yeah.
couple of slides. If you, they're hidden though. That's the only
Hmm.
issue.
No worries, no worries. Give me a moment. I can then pull up the actual parent slides. One moment.
Sure.
Thanks, Niyati, for pitching in. Um,
No worries.
yeah, I think I got them. Mm. Yeah, this was a hidden slide. One moment. Yeah, these were the other questions that I was talking about. How does the system prevent the hallucination? So, by explicit, I think I'll just go ahead with the screen share with this. Yeah, can you see my slideshow in full
Yes.
screen? Yeah,
Yes.
perfect. So this was the second question that I was talking about. How does the system prevent the hallucination? So we have the explicit grounding prompts. We have the tool enforced data access, ensuring that only what is returned by the tools are returned by the system. And exact number quoting, we are not rounding the numbers up. We are explicitly asking the system to provide the actual numbers, and also the parameterized SQL. That means um, whatever information or whatever query that was coming in. For example, using an album name, that was used to query the actual table, which was our Chinook SQLite table. Sorry, a Chinook table that was loaded to our memory. Now, that was a parameterized SQL. And also, in case where it did not generate a proper response or it did not come up with a proper response, it will simply say that I could not find a proper response. That is the failure instruction. And then, yep. Um, yeah. And yeah, another thing is when you ask the same query, it attempts to provide the same response every single time because the genre names, for instance, they are from a fixed list. So you can't come up with new elements for that. So that also prevents hallucination. So there is no confusion with respect to that. That means only if the element belongs to this particular list, you will be fetching the information corresponding to that. So that also prevents the hallucination. So because if you ask a totally different genre, then the LLM might hallucinate because the LLM might be is trained for conversation, right? So, which is why the tool enforced data access ensures that the LLM does not come up with anything on its own. Now, the next question was explain the identity verification flow, which we already discussed. And the first part was that the verify info function, which is the entry point. And this one should be cleared for any of the subagents to provide personal data information. Then the next one is the structured extraction. That means it needs to provide the output in the expected format. If you remember PyDentic, we use the data validation library for that. And also, um, we have certain formats. That means email ID, phone number, customer ID, either of this. Only these three are permitted. And then uh, the customer ID is injected as a system message. So that means once the customer ID is identified, this customer ID is injected to the functions directly and not from the user's end. The user does not explicitly say the customer ID again, but by default, it is injected as a system message. And then you have the interrupt function in LangGraph that waits for the user's input in case the customer ID is not available. So all of this ensures a security design so that user number 53 does not get access to user number 7's personal information. Yeah, these are some questions that I wanted to cover. One moment. All right. Okay. So, all right. Mm, yep. So that was the last part of the high level explanation of what was the agentic system. So I hope I cleared some concepts with respect to building agentic systems because ultimately it is just functions and we have agents which uses LLMs and which uses tools. Tools are your actual functions. Like, specific input and specific output. So if you ground your agentic systems or your LLMs using such tools, then the quality of responses would increase. So that's what I wanted to highlight because otherwise it can hallucinate left, right, and center. And we have observed that especially with directly using LLMs. All right. Any questions? I don't have a lot of time for questions, but let's see. Um, yeah, Sri, you were asking about my setup, right? It's nothing fancy. It's just my laptop, my tablet, and the writing pen. That's it. Uh, is multi-agent architecture similar to microservices? Mm, multi-agent architecture can be, yeah, you can consider it similar to microservices, but using LLMs. Yes. Okay. Then will it slow down the response? Are you asking about a multi-agent system? Yes, multi-agent systems, the latency will be a bit higher than a single agent system in general because it has to do multiple routing, um, come to the correct agent, perform the tooling, come back and then go back to the start and then give you the response. Yes, the latency might be higher, but especially in instances where a slight increase in latency is fine, but the accuracy is more important, then you go for multi-agent systems. Using sampling demo tool is not working for me. Are you not able to access this web page, Venkat? Like we have a music application, what other examples do you expect? A lot. Like for example, um, um, starting from what do you say? Starting from verifying regulatory compliance documents in BFSI, in a supply chain, to implementing sales support representatives or sales support agentic systems. I've seen quite a lot of agentic systems that were deployed by different organizations. Similar to this, but quite different from this. From an architecture perspective, from an implementation perspective, from a data set perspective, from a tooling perspective, all of this, from a guardrail perspective, all of this. So, is there a framework to test the agents? Good question. Framework to test the agents. I generally use Pydantic for that. Yeah. Any example specific to DevOps field? Mm, DevOps field, I can't think of any at the moment. Is Python mandatory or can we use .NET? Uh, yeah, see, the thing is, Python is not mandatory, but most of these agentic frameworks support Python. So um, there are agentic frameworks that support other programming languages as well, but I have never personally used them. So I think you will have to take a look into it. Or there are no-code agentic frameworks as well, if that works for you, like N8N, for instance. Sharad, thank you very much for your feedback. It means a lot. Thank you. All right. You can, but you're not able to give any prompt. Can't you type a question here? Um, like in this, and then click on send. Or can you click on the new conversation? This is a publicly available link, so it should be possible for everybody to use. That's what I was wondering. Yeah, thank you. You refreshed it and it's working. You're welcome. Yeah, no worries. Okay, I have a hard stop right now if that's fine with you. Niyati, is
Yes.
that good? Have I covered everything? Are we
I
good?
think I think we have covered everything. Abhinav has been kind enough to answer all the
Yeah,
questions.
Abhinav, thank you very much. You really helped me out because it wouldn't be possible for me to answer all of those questions. Thank you very much. Yeah.
Yes, I have also launched the last poll where we ask everybody for their feedback. Uh, and if there are certain questions that you guys have, Justin is taking the session tomorrow also. He will be available and you can ask your questions. You can join tomorrow's session. It is the continuation of today's session. So we'll get into details of multi-agent systems and again talk about how to answer questions in interviews about multi-agent systems, right? So do join us tomorrow. Thanks, Arthur. That's a very long thank you. So welcome. We are delighted that we could help out. And so see you guys tomorrow. I will stay here for a couple of minutes to see if there are any questions regarding the program. And I think I'm just going to share my screen, Justin, so that people want to know what are we covering tomorrow.
Sure, sure. Yeah. There you go.
this is what we are going to cover tomorrow, everybody, as you can see. So we'll cover topics on deep orchestration, database deep dive, accuracy validation, state management, which is important, logging, error handling. A lot of you would want to, handle that because debugging becomes like a large part of actually taking systems, AI systems into production. That's exactly where we'll go after error handling into production grade scaling. Uh, we will also check the performance and scalability, how to test that, how to decide that, uh, and then we'll get into advanced deep code of it. Like Justin said, it's the base of everything is coding, right? So we are going to understand the implementation side of it. And then we are also, like today, we picked up 3 questions that are asked in interviews. Same way, we are going to pick up 3 questions tomorrow on multi-agent systems and give you some answers. So that's a sneak peek into what we do over 3 months in our interview preparation, by the way. But because this is like a crash course of sorts, this is just a starter course or starter sessions for you. The what we have covered right now, what Justin has covered, we cover over weeks and hours in our actual program. So do join us tomorrow and make the most of this. And recordings, don't worry, recordings will be provided. So later also you can do like a follow along and then try it out yourself, build it out yourself, all the GitHub repos, everything. If you have missed out on anything today, don't worry. Join us tomorrow and we'll cover everything. So Abhinav, thanks a lot for taking all the questions. I think you have answered everything. A lot of Dhaval, thank you for complimenting Abhinav for on the way he's answered everything. Yes. Can you, yeah, sure. If you still have questions on the uh, programs that we give, the Interview Kickstart programs, that also we can cover again tomorrow. I have anyway posted the link of our program advisor who can take you through uh, your upskilling roadmap in detail. So yes, if you have answered the poll, thank you so much. If you have booked a session with us through the calendar link that I've shared, you can drop off. Thanks a lot for joining. Thanks, Justin, for joining. See you again very, very soon. And yes, have a great rest of the Saturday, guys. Thank you.